top. This is getting to be a big problem. All of this. Look at this. The spread. The mess. We got to deal with it tomorrow. We're going to do specifically a cleanup stream. And I think I can break down what's on the breadboard because we're done with the mixer circuit. We know it kind of works. So I can do just a end-to-end cleanup of this shop to get ready for Julian on Saturday, and then none of you will watch. None of you will be there. Nobody's around on a Saturday. That's okay, though. I don't mind if you guys aren't here. I do these wonderful streams where I bother my in-real-life friends to come into the shop and actually show you guys the breadth and width of their talented talent. Or the breadth and width of their talent. That's what I'm looking for. But nobody's around because everybody watches me at work. I'm not around most days either. But I know the name Paloozer. Paloozer, more like. Why did you give your only viewers strays, Bother? You scared them away. No. Why do you have such disdain for your viewers? I don't know. Twitch taught me it. I learned it from you, Twitch. So folding over the ends of the little things did perfectly. I need to find a better way to fold it. I think using something like these might be the best way. These flat-nosed pliers might be the best way to do it. These might be the best thing that I've got in order to fold over that little piece, but they're so big and this thing is so small. But I think these are the width of the, no, they're a little smaller. They're only a little bit smaller, but I think they can put a good crease in it. So other than making like a jig specifically for doing that, I think that's the best bet. But we'll get this one working that I haphazardly folded, and then I can do a full install on the other keyboard, and then we'll never talk about it again. But getting this thing to work, I think, is going to be a whole stream. I need to check ohms on the pins, which is a lot of pins to check, but we'll check the ones that count. Square-nosed forceps. What are my forceps like? Let's get these are the big medical ones. This is as square as it gets, and it's tapered in. The other ones are just simple clay working forceps. I need to buy more specialized tools, huh? No, Bother. No, you don't. No, you don't. Yeah, these would cover it, but the problem is with them being tapered, then I'm going to get the angle wrong. Like what it wants to do is what this one here did, the one facing horizontally. It folded at the interface of the solder mask layer, just because that's where the force is. So I had to press the issue for this one and this one in order to get it to fold before where the fold is, so that it wasn't folding on a weak spot. Which I'm sure this would have been fine. I just wanted to have the visual confirmation of the traces being soldered. I probably could have folded it there and just laid it down like vertically so that it was a 90-degree angle, and the traces were then facing down and would solder down. Honestly, in the end, what I really should have done is put those on the underside. I should have put all those on the under layer, because that's perfectly acceptable, and I would have been able to run with that. It would have meant that there's like 10,000 of these guys running under the board, but that's fine. A little bit annoying for troubleshooting. Then again, this design with all the muxes is not exactly kosher. It's just what I came up with. Oh, I need to start soon. No, not overlay. That's setup. There. I'm starting. All right, I'm gonna do Discord message. Where's Discord? Where'd that go? Discord. Here we go. Need to do my end message. Admin. The secret admin room where literally the only thing we do is update. And I'm the only one that does it now. Now that OctoJ is dead. He's not dead. He's just tired. He's sleeping. We sent him to a farm where he gets to play with all his friends all the time. No, he got married. He got married and moved to America. Actually, I think engaged maybe. I don't know what the status is. But he got a life. Which good on him. Good on him. He was a friend of mine. He's still alive. He is a friend of mine from the Red Letter Media streams. Back in the day, he was a moderator for them. Now I got kicked out of moderation. I was just talking with them. They're the people who are here for my stream from the very beginning. Like, what's his face? Oh, damn it. John something or other. John Kilo. You guys sometimes will see. There's a few others. All right. Cool. That's looking functional-ish. We may have to spend some time in software today. I'm hoping that the hardest thing that we have to do is just rearrange the rows and columns to where it'll work as a keyboard. That's what I'm hoping. The circuit should be exactly the same thing that I installed in the other keyboard that has worked for years. So once this thing is launched, that's it. That's the end of the project. Insofar as we're working on it recently. I mean, I'm not going to resurrect, well, at some point I will resurrect it, and I would like to actually use a bare RP2040, just the chip, and put that on that board so that there's less hardware, so I don't need those Max 309s, the muxes. I think having access to all the pins, including the ones meant for the EEPROM, I might be able to get everything locked away, but I'm not sure how the I'm not sure how the RP2040 works. Let's look it up. RP2040 minimal setup. Minimal RP2040 board from technology.com. And it's broken. Cool, cool. Hardware design with the RP2040. Oh dear God. This is a 900-page document? No, but do they have an external EEPROM? Come on. Come on. Consists of 4 main elements: power, flash storage, and crystal oscillator. So we need that storage. That might mean that I'm limited in my I/O. I may not be able to actually do that. How many I/O did I need? Trusting my numbers, which I probably shouldn't, I need 30 I/O. 30. In order to run this board. Oh, but I don't need number 7. I don't need for some reason, number 7 has nothing in it. So, this one is totally pointless. What about 6? 6 has everything on it. Oh, so I'm running 7 and 6 together. What a weird thing to do, because there's nothing on 7. Interesting. Where's my mouse? Where did my mouse go? There it is. Bright mode is very, very bad. Very bad. We should try to figure out how to night mode our sketches. A night mode and a drawing tablet would be great. I have the drawing tablet. It's just, I don't have a place for it. I would need it to like hang above my keyboard or something. Oh, EEPROM has its own P1.6 and P1.7. No, that's this chip's EEPROM. That's not the same thing. Why am I getting confused? So 30 I/O. I can double check that. So that's 10. Is it 10 per side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm counting 24. So if that whole side is used, that's 12. Mahalo just subscribed. Mahalo, thank you so much. Very, very kind. 66 months. The devil, you say. With just a yay as the message. Hey, thank you. Thank you. That's very nice of you indeed. Okay, how many do we need? We've got 12, 12, 15, 16, which is all those, 17, 18, 19, 20, 21, 22, 23, this one I think is 24, 24. Yeah, that's basically, hold on, 24. Then 2 for I2C. That's 26. And then are these taken? 27, 28, 29, 30, 31. That's 31 IO. Yeah, 31 IO. 0 to 25. And then in 26, 27, 20, 29. Can't use these, I don't think. Can I use the QSP serial clock? Because if I could, that would bump me up. Oh, and we've already got I2C. Wait a minute. So this is 25, 29, and then my 2, so it's minus 2. So it's 31, 30, 29. So it's exactly the right amount of IO. That is exactly the amount. But then where does, I guess the flash goes into the QSP thing, unless it's up somewhere else. So I might be able to do the I2C EEPROM. Unless it's SW clock and SWD. And then the run pin is a separate thing, but that's still something that we would need. But, and then X in and X out, I don't even know what that is. Decoupling, I'd have to read that. I have to read this. Support in place decoupling close to the power pins, ordinarily recommend 100 NF. They recommend 100 NF because everybody does. There are better capacitors to use these days. You can get 3.3 microfarads in there with low ESD and all that stuff. Firstly, in order to be able to have enough space for all the chip pins, blah, 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 blah. I will need to read this. Internal voltage regulator. This is 1V1 power supply. Nah. Flash storage. Okay, so that's QSP. In order to be able to store program code with an RP2040 that can boot and run from, we need to use flash memory, specifically a quad SPI. Why don't you put that in your chip? Put that in your chip for us, please. I guess it depends. Like you can configure the flash storage depending on the application. For us, it's a generic QMK keyboard that I'm going to try to put a bunch of bullshit on. So I guess whatever. Yeah, it'll need its own flash chip. I have flash chips. I've never used I2C flash for anything really. I have chips, but they might be too small. Not physically small. They might be incapable. So I might have to buy a modern flash chip, in which case I'll just buy whatever they're using and put that in there. But I do need it, and it is required. And we do have the pinout for it. Oh, did I ask what X in and X out was? How dumb of me. How dumb of me to not recognize that X is crystal. Recommended crystal. Minimum 12, typical 12, maximum, believe it or not, 12. That's very unspecific. Thank you for that. Usually they would give you just a couple decimal places, but I guess they want it to, you lock in on 12 megahertz. Minus plus 5 ppm. 25 plus or minus 3 degrees Celsius first year. What does that even mean? Pulse per minute? So it has to be per minute. It can't be more or less than 5 over, under, 5 off. Crazy. USB, make sure R3 and R4 are close to the RP2040. They get 22.4 or 27.4. Well, there's already a ton of stuff, of resistors on this board ahead of the D- and D+. So we should be pretty good. That's crazy. So this will work without a mux. I can actually get this thing to run, where's that? Yeah, I can get this thing to run the whole keyboard using every single one of these I/O. Every single one. What happened? Where'd the music go? Oh, it's coming back. I'm going to skip ahead. Every last one of them will be used. Yeah, so today we're going to be working with this a little bit and trying to get it working. And then tomorrow we're going to clean up some of the shop because I really need to clean in here. Things have gotten over-cluttered, well over-cluttered, and I need to start putting stuff in places in order to make room for Julian, who's going to be here on Saturday. So we're going to have a Saturday music stream, hang out, make boopy noises, and test out the mixer that we've put all of our heart into thus far. Julian was asking, like, am I going to blow up my headphones? And I'm like, no, I put my own headphones on the line for this. You should be fine. If anything, he's going to ask for me to make it louder, which I can accommodate very easily because it's just a matter of changing out the feedback resistors here. This one and this one, I think, are the ones. We'll have to investigate. Oh, yeah, and it turns out I got the program manager for my AutoCAD subscription basically, as per my last emailed me. I'm going to pull that up. Hold on. As per my last email meme. There we go. He basically said, I said in Slack that the copies would be re-upping after they, like, right after they expire. So he was like, I basically was like, oh, great, I got as per my last email. But it turns out that everything's fine. Everything's totally fine. It's just I didn't read the Slack channel, so that's on me. We will, of course, be doing further sponsored streams. And then someday, one of these days, I don't know what day it is, can't really tell you, I'm going to schedule a haircut and actually get my mop cleaned up. This is ridiculous. It's getting kind of ridiculous. It takes like 2 hours to dry in the morning. And then when I get outside, especially in this frickin' weather, I have a hair helmet. A hair helmet out of frozen hair. It's bad. And then I'll rein in the beard a little bit and I'll look like a totally different person. You'll see. I look like the bother you all know and remember. That or my scraggled looks have been hiding my aging, and you guys will suddenly see this withered old man leading stream. I think I have something like 4 years until it all starts to show. But Julian's gotten all salt and pepper. I'm getting a couple little lines here, and one of my college buddies is just completely. There's more white than there is dark. It's getting crazy out there, folks. We're not even that old. What's everybody doing? It's quiet. Because I started like a couple minutes late. It's just taking people a while to filter in. I guess the QMK keyboard in the title isn't as alluring as other things are. But I want to get this project like done. If this doesn't get done today, then it gets put on the shelf for later on. Because we got this thing on Saturday, clean up on Friday because it's absolutely necessary. This is getting out of hand. This is not a good state of things here. I need to clear that table off, and then I need the wood down here to be visible. I need to get all this crap up and away, and then modular synthesizer stuff I can put in a bin of its own and make room for it all the way over there. Because we'll start with the corner and move our way out. And those two are probably going to go here. And then we need to look at these bins because these bins are getting way out of hand. And I think what I can do is just sit on the floor with y'all once we get this stuff out of the way, right? I sit on the floor with y'all and we just go through some of these bins and figure out what can be reallocated, moved, and reorganized. It'll be good. It'll be a nice, neat stream. It'll be sort of a this, then that, then the other thing. And we'll see where we get within our time limit. Time limit is important because I need to do IRL stuff after streaming. Unfortunately, lately with the dog, I can't just stream well into the night. Although there are people to help me out with that today, so I could potentially go very late. Hopefully, we don't have a lot, like too much to do because I've already got software that works on this keyboard depending on the wiring whether or not it's been rearranged These are all through holes, so they hurt when you touch them. Should we get started? It's only been 20 minutes. One person per minute is filtering in. Yeah, we're getting there. We're getting there. It's all good. What's that? Oh, res update. Burp. Burp. I can't believe I have exactly the number of I/O to run this thing. So I would need to get a 12 megahertz crystal, put that on there. I don't know what speed the, what do you call it? What speed my Omnipods were. If that was 12 megahertz, that would be a, how do you test a crystal? I've never really figured that one out. I guess you hook it up with the capacitors, but then what after that? How do you test it? I don't know how to run a crystal. I don't know anything about electronics. Why are we bringing fuzzy logic into this? So here you're taking the immensely tiny signal of the crystal with a voltage level, and you're biasing it on the voltage level with a huge pull down, so that you're taking a little tiny bit of that 5 volts and you are biasing it to where it's triggering the transistor as an amplifier, and the transistor as an amplifier is working with that VCC in order to pump it out to the main part of the circuit where you can measure it as a big wave. As a big weave. Big Wave gifted me a sub to Djibouti show the other day. I was hanging out on the internet, as I do, you know, just walking around like it's a big mall, just hanging out, causing trouble, doing all that stuff, leaving awkward comments with a partner badge next to it. I should be more stupid about that. I don't have it within me to be that, like, I can't handle being that embarrassed. But what I should really do is go around with a partner badge and really embarrass myself and just like do stupid shit on people's streams, just say weird stuff. I've done that by accident drunk before, and I apologize to Olivia Manser for being awkward. But but if I did it intentionally, that would be something else. But anyway, I was hanging out and just seeing what Djibouti show was up to, and Big Wave, who I think is under a different name now, gifted a sub. So that was amazing. That was very, very nice of him to do. He's streamed for a little bit and still is. Every now and then he'll go live with like a couple people watching. But it's good stuff. Boom, 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 boom. And I think Julian's intentions for this circuit was to have a stereo output that he could just plug into my mixer over there, and then that would be that, right? It would all be at all the right volume levels and wouldn't require mixing. My intentions were to have him and Dave coming in on their own stereo channels, and then I would mix it with the mixer to a master mix that I could listen to also on that mixer, because I can send and receive audio from individual channels into OBS. So I can send my OBS monitor into these headphones with pretty small amount of delay. I've got a lot of audio stuff plugged into this computer, but pretty small amount of delay, and these are B&Os. They're pretty flat response. They're not quite Sony MDRs in terms of like studio headphones, but these make a good substitute for studio headphones. They're not too generous in any of the frequencies. They do a nice little reproduction sound, because that's what I look for in audio equipment, is when I'm listening to something, I want to hear exactly what they hear in the booth. So, but then we can get everybody in balance this time. I think last time it was either the music was overwhelming or it was way too far in the background, and that's a tough balance to strike. And you can't exactly ask your audience, you know, what they hear, because some people, like me, I listen to stuff on speakers, which everybody hates. Everybody seems to hate listening to stuff on speakers. But I've got good speakers. They're studio monitors, so they're really only going to my ears. Everywhere else gets sort of slightly worse sound. I enjoy that because I don't like having wires hanging off of me, hence the insulin pump that I have and all that other stuff. Most people are like, if I'm on the computer, I'm on headphones. I'm just like, I live with old people, and they might need to like yell something at me if they need help with something. So I do speakers, and I keep them very, very low volume, which means that streams like Atom Plays or YMS Plays, and streams like who else does this? I think Tomato does it too. Where if they're listening on headphones, things are a little different, and that music feels like it's in the background at a decent volume level, and your voice is loud enough on top of it. But when you move that over to speakers, it becomes the music or the game is just non-existent, and then your audio is fine. I mean, a lot of the times that's to like balance out screaming and stuff, but that's what a compressor is there for. You can have a compressor that clips you just barely, but it keeps you within a reasonable volume of them. That's what we have here because I use power tools. Right? Things get really loud sometimes. And so that compressor keeps everything within the normal hearing range. It sort of misrepresents when I get louder and when I get softer. When I'm speaking to you guys softly, you can still hear me. When I'm yelling at you guys, it just sounds like I'm more emphatic with the words, but in reality, I'm actually being much louder. There's a huge dynamic range of audio here, but I've knocked it down in order to make sure that people with varying devices can still hear what's going on. Like your cell phones and stuff like that. People do watch on the cell phone. I don't know why they do that. Why do they watch on the cell phone? What are you doing? It's as the art was meant to be digested through a screen that fits in the palm of your hand. People watch movies on their cell phones. It's crazy. It's a madhouse. Man, what's going on? Is my bitrate bad or something? Bitrate looks okay. 5K. Oh, and then in the background, I don't have time to work on all this stuff. In the background, I need to set up something that will check to see whether or not YouTube is live. Because we had a 4-hour incident the other day where I kept streaming for 4 hours after the stream. That's really bad. Luckily, I wasn't recording it. If I was recording it, it would have filled up my hard drives. I don't need that. But it went up on YouTube, and I don't have any way to edit it away because the YouTube editor gets real dumb when your content spans more than an hour. I've got an 8-hour video. I'd like to chop off the end 4 hours, but I wish I could just tell YouTube to do that, like in text, and then they'll figure it out. Say, cut after this time, and it'll just do that in the background. But instead, it's like, I've got to interpret your whole video. Let me work on that, and then it doesn't proceed. It just gets bogged down in low priority computing jobs, low priority encoding jobs. I wish they'd work on that a little bit. Yeah, the one from 5 days ago is 8 hours and 19 minutes, and I needed to cut after like 4 hours and 30. 5 hours at the latest. Can I edit this? Download, add to queue, save to watch later? No. I have to go into the editor to do that. Hup. Oh, did I not? I didn't open up YouTube chat. Oh. My fault. I'll catch up with you guys. So sorry, YouTube chat. Where's my... Wait, am I not? Let's go to home and see. Oh, yeah, I am. Hold on. Let me open it up. There's probably like 500 people chatting in YouTube. No, there's nobody. Is this on... Wait, which one is this on? Oh, I don't want this one. I want the other one. I need to go to... Oops. No, that's fine. Oh, bother VOD. And I need to pop out the chat from there. Open that up. Mute myself. God, it is cold in the Northeast. We got one of those Arctic blasts. Typically, this time of year, we're kind of like oscillating, and especially recently with the way the environment is being slowly eroded by mankind, we get like hot, cold, right? But it's in a much smaller scale, and it'll be like barely freezing, and then like a blast of sunlight will knock all that away. Instead, we got a super duper Arctic blast, so now we're knocked all the way down to like the 0 mark in Celsius. There's several degrees outside, and so you go outside and your face just starts hurting with the light breeze, but it's dry. There's no precipitation. We're supposed to get a little bit of snow today, like little sprinkles. I haven't seen that yet. They usually predict you're going to get 500 inches of snow in 12 days, and then in 10 days you're supposed to get 200 inches of snow, and then it's like in 3 days you're supposed to get the snow century of the lifetime, and then it's like, never mind, it blew away. That's how it always is with these weather predictions. I don't think they can go more than 2 days. I think the modern weather prediction has fallen asunder, and they've fallen victim to things like the Koch brothers hiring a bunch of weather experts in order to predict, like manipulate crop prices and stuff. And so we've got not the best weather people on the job, and then I think we lost a satellite at some point. This could all be misinformation. I'm not up to date with this stuff. I read about it like 5 years ago, but I think our weather forecasts are not really good 2 days out. I don't know. Just me. Could all be conspiracy theories. We love misinformation on this channel. I try to stay out of stuff that can be considered misinformation. You guys see, I'm like the most white bread, just, you know, dog shit neutral opinion person on the internet. Just because, you know, all of these argumentative things that people do these days are not the point of this channel. It's not what we do here. We work on electronics. Oh boy, I'm looking forward to getting my fingies into cleaning this place, because I'm sitting here on this pile of just crap, right? It's a dump. Things have gotten out of control. It's a bit of a dump in here. And I think neatening and organizing is going to help us kind of like get our head together. And then getting, for me, I think maybe I'm going to try to like, Saturday Julian's here. I don't know if my haircut place is open on Monday. They might be open on Sunday. I'll have to check. I'll try to get that done as soon as possible, because I need to get my hair under control. And it gets warm next week, so so I can survive without the big mop of hair on my head. And hopefully this time I can schedule somebody who has time instead of just doing a walk-in. This one was somebody who just had time, and it looked a little awkward for a while. I mean, I guess growing your hair out looks a little awkward, but this has got to go. It's got to go. I got to neaten up again. I did semi-fix my sleep schedule. I got to bed at 1 a.m. 1:30 actually. 1:35. It was 1:40-ish. But it was, you know, it was normal, good time to get to bed. I'm going to be shooting for that this week, is trying to get to bed at a reasonable time. I am in the first day of fixing my sleep schedule, so naturally I feel like crap. Streaming is helping a little bit. It's actually getting me to like put my attention and energy forward and kind of like wake up. But like in general, the first day of that's going to be terrible. Probably the first week is going to be awful. And then your body kind of falls into the rhythm, and waking up a little bit earlier feels good. So I was up at, I think, 7 o'clock this morning, which is not, for some of you out there, I know that's nothing. You guys will say, I wake up at 12:30 at night to go to work. I understand that there are corner cases, but 7 a.m. is a nice little wake up time. 7 a.m. is a nice time to wake up. That's when my dad leaves for work. What a dump. This place is a dump. It's like the dump's dump. If the dump had a dump, this would be that. It's the dump's dumpy dump. Dumpy, dumpy, dumpy dump. I gotta find a job for this thing. I was thinking of turning it into like my audio interpreter, so that I could do the lavalier microphone mix on it, and then have that also have a compressor. But I don't know if it would be any better than my super duper digital compressor. Better or worse or what? I mean, DIY audio wise, I don't know. You know, analog electronics being what they are. That, or I get the tiny FPGA and we put all of the audio into I2S, and then I digitally manipulate it with this guy. Then I'd have to run a UI. It's like the module testing module. It's a big project, and you can take on these big projects, but they'll become overwhelming. I want to make a PCB for the module testing module, and then it's a software project, which I'm not good at, but I could turn it over to software and then make it, you know, make modules that make it do specific tests, and those will roll themselves into a UI eventually. UIs are rough. There's a bunch of projects out there for microcontroller-based UIs that give you like a minimalistic sort of way of programming the different interactions and stuff, and the different screens, and like you can roll with those and get going pretty well. It's like learning another language almost. You need to kind of learn how they structure things in order to work within their programs. And then also on top of that, there are a bunch of visual UI tools where you can make these dog shit industrial product style UIs, which is maybe what I want to do with the audio, like the headphone, or sorry, the microphone manager, because then I can use one of the color screens. I have a color touch screen sitting somewhere around here, and maybe a Raspberry Pi can speak to the tiny FPGA. I don't know. I don't know if I want, so what the whole purpose is that I don't want immense amounts of audio delay. And if I use the Raspberry Pi, that thing's working more like a computer than it is a bunch of logic gates. So the tiny FPGA manipulating the audio would be ideal because it works like a bunch of audio or a bunch of logic gates. If I put like a teensy 3 point whatever, 4 point whatever on it, I think there would be a little bit of delay there too, even though it's a brutally fast microcontroller. It still has to take I2C in, interpret it, put I2C out. We tested that with a sine wave, didn't we? We tested that with a sine wave when I was building the audio tester. We were testing circuits for that audio the module tester. We're testing circuits for the module tester, and we had an I2C sine wave outputting into the input, and then on a separate channel we outputted that sine wave that was input with the Paul Stoffrigan tools, the audio tools. And the delay of the two sine waves was microseconds. So it was visible zooming in on the scope, but they were practically on top of each other. There was, of course, some delay, but it was microseconds. So I could technically use a Teensy4. The tiny FPGA has been sitting in a bin, and I've really wanted to have a job for it. So having like super duper, see, the thing is, if you have super duper no delay, you can then put like a microphone, or sorry, a headphone plug on that super undelayed audio, and it won't befuddle the person listening to their own voice. That's what the AT2020 USB, even the one that Critical uses, the AT2020, he uses the AT2020, which I can respect. That's one-to-one audio reproduction. It's a very good microphone. Requires a little bit of post-processing or maturity on your part not to suddenly scream or bash the mic in any way, because it'll blow up other people's speakers. I've seen people buy that microphone based on my recommendation, and then they blow up people's houses with their audio because that microphone is completely unbridled. It's a one-to-one reproduction, so it's like actually having somebody scream next to you, and it gets very loud and very soft, and it's a good mic. But one of the versions of the AT2020 that goes directly into USB, good when you're starting out stream, has a microphone, or it has a headphone plug on it, and Critical uses that. He has his little shitty Apple headphones with one ear in, just so he can hear when he's in the sweet spot of that microphone and he's actually broadcasting, full audio. It's tough. You got to be careful about that. And that's actually what I do with the mixer. The mixers that I have this one-to-one reproduction, very fast reproduction of your audio, your main mix. And so when I am streaming, I'm listening to my own voice on top of everything else. It helps. It helps you stay within the right parameters of the mic, and to know when you're clipping and stuff like that. But I could do that with an audio box that I make if it's fast enough. I don't know if that couple microsecond delay, I think it's measured in milliseconds, the befuddlement factor, what you need to be within in order to have listen to yourself talk and not be befuddled. Of course, the other problem is that when I'm talking, my skull's vibrating. And so if I'm listening to myself, I'm listening to two separate mixes of myself, what my ears interpret and what my audio equipment interprets. So it might not be a good reproduction. That's why, in order to balance all the audio initially on my streaming setup, I would record little clips of my talking and listen back to them. So I had the monitor being recorded, and I would take the different bands of EQ up and down while I recorded it, and then I watched that recording with headphones on. So I don't know. This is a good reproduction of my voice. I don't have a lot of bass boosting going on. Probably could use a little bit, but I kept it out. I wanted to keep my voice sort of true to life. I like a good clean bass line. Should we get started? We got QMK to do. I don't know what I'm doing. This is a very good song. I'm gonna let this song complete before we get started. And what do we got up here? We got LM1117 stuff. We got RP2040 stuff. Just stuff. I'm inundated with stuff. That's part of what tomorrow is going to be all about, is cleaning up. Father, if you got rid of start soon, does that mean stream isn't going to start for a while? Oh my God. Good album. Terrible cover. Good album. I don't like the cover at all. This is OTT, and it's called Fair Children is the album. It's from nine years ago. Why is everything that I peaked 9 years ago, chat. I peaked 9 years ago, and I think I'm chasing that ever since. That's what's been going on with me, if you need to know. I haven't even begun to peak yet. Anyway, here we are. Welcome to my stream. I am currently kind of stewing over the fact that I have just piles and piles of garbage in this shop that have piled up on top of itself. And it's not even garbage, it's project stuff. We're going to address that tomorrow, because today we have the opportunity to finish a project. We might be able to finish the QMK keyboard project. In order to do that, I need to get the software to work with my PCB. The software that I have works with the other version of this project, which is very close to what this one is. It's sort of a logical progression of designs. You see, I started off with the ARP. Ow, every time I touch this board, it's all spikes. This is a code 10 keyless keyboard, right? The code 10 keyless keyboard uses the Sonics microcontroller. And that's actually two of them. One of them is doing lighting and reprogramming, and the other one holds the keyboard's main program and does USB. Through the years, Code has come up with several iterations of how they run their keyboard. They used to have this sort of U-shaped board with two big standoffs that would sit right here. But since then, they've gotten to the point where they want to have just one big old PCB running the show that holds everything in place. And actually, come to think of it, you could have a flexible PCB for this entire board. Anyway, point is, Code does some weird stuff. What Code does with the layout of their keyboard is they break up the rows. Everything has a column, right? Rows and columns in matrix designs help keep the number of pins down. And so they have a column of keys, and then they have rows of keys. But instead of all of these numbers being checked at the same time, they split it up. They actually have rows that are split up and near home row, so that when you're inputting stuff quickly, they're able to scan through and catch those key presses. It is a system that I do not know if it has any advantage or not, because I think all the mechanical keyboard folks are totally happy with their mega rows. I think they're totally happy with it. But anyway, that system from our standpoint represents a little bit of a challenge in laying things out. And I've already done the work. I've done all the work to plot out where all these rows and columns are and what pins of the microcontroller they go to. In the previous version, of the takeover of this keyboard with Quick Mechanical Keyboard, QMK, we have the RP2040 muxes, because muxes allow us to have one sense pin, and then all the other pins can be switched to digitally. Unfortunately, my muxes are analog muxes. And what the muxes allow us to do, where is my mouse? I always lose the mouse. Here we go. What the muxes allow us to do is flip between which common pin goes to which row or column. So we have one for the column, and then since there's 8 of them in these things, we have 2 doing all the rows. And so those Maxim chips, when you give them a signal, 0, 1, and 2, and enable actually, enable 0, 1, and 2, when you give them that signal, it'll flip one of these internal switches and apply the input to the output, right? But they're analog. So these are analog, and they work in a range of plus minus 15 volts even. They work at 3 volts. So we're running everything at 3 volts, and these chips are doing their job, but they're a little bit slow. So I've had to put delays into the software. But in order to be true to what I built physically, we reproduced exactly the circuit on the PCB. The only difference between the circuits are that some of the rows and columns have been swapped in order to make layout clean. And I think I did that with the real thing. It's a little bit mad here because sometimes I'm coming in from the outside of the chip and sometimes I'm coming in from the inside. Sometimes it's inside outside, sometimes it's outside outside. It's kind of crazy, but the thing is, like, when I upgrade this even more, like the next iteration of this project, I can run all of the I/O straight to this chip. The Pico Pi does not have all 29 I/O. Some of the analog pins we can use as I/Os, and we can get 29, and I think I need like 23. Those are conductive. I need to get those out of there. I need to get these out of here. They're conductive. These little strays of, that would have been real bad. Hey, let's short out USB. Cool, man. Sounds like a good time. Get these out of here. So, JLC PCB is having a nice little deal on flexible PCBs. What a flexible PCB allows me to do is to run all of the pins of the previous microcontroller into my circuit board. And so instead of having 10,000 wires on this thing, oh, there's a short right there. Instead of having 10,000 wires on this thing, I can have everything nice and neat and organized on a little flexible PCB. These things used to be so expensive. Hey, what's up, Groovy Something? How you doing? What's this Groovy Something? It's a weird name. There we go. So I can run all of my lines onto the PCB, all the pins of the microcontroller, even though we don't really need all the pins of the microcontroller. I need only these to work. Twitch, yeah. Questlove. Somebody named Questlove saying Twitch has weird, you guys all have weird names. Thanks, Questlove. I feel judged. That's a personal experience from Groovy. He went on a Questlove stream and got criticized, although I think he realized his mistake right away. Wow, that heated the other side of the resistor instantly. That was weird. Okay, so we are at the stage of this thing where I'm kind of going over the solder and just taking a look at everything, and I might need to bring out the multimeter. It was the only one that wasn't like crazy. So I think maybe the next stage is to get out, that doesn't look right. Get out the multimeter and do a couple little tests on this just to see if we're getting good continuity all the way to this stuff. The way we can test it two ways. I could put the multimeter on this pad over here, and that would technically test through, obviously we can't test these three, but whatever. That would test through the interface. What I did is I took the, hold on, let me get the other board. I have two boards because I have two keyboards. I took these lines and I used the desoldering brick. Jeez, what is that thing? This is why I need to clean up around here. These guys, oh, damn it. I took these guys right here and I folded them in half. I desoldered them, folded them in half, and hopefully that's not going to cause a break in the connection. These don't fold very much. You don't get a ton of folds. Light flexing is probably fine on these, but I mean, again, we've got these tiny little traces, so these will be prone to breaking. I hope we didn't break any on the other one, and we'll find out eventually. But I desoldered them so that they were a little bit more flexible, and then I bent them in half. And doing so allowed me to actually solder everything down and get somewhat, not a really good visual representation of the fact that it's soldered. Actually, that's not really that good of a visual representation. But maybe just maybe this worked out. The other one, I think I'm going to try to bend a little bit harder so that there isn't a gap. And then it'll look like the solder's flowed up all the way over it. And I think that solves our issue. In the next iteration of this, I will do pads on the bottom instead of the top. Maybe I'll also do pads on the top, but those wouldn't be that accessible. So we wouldn't get solder to flow over to them. I could maybe investigate whether or not I can do what's called castellated holes, which are what these are, these little amogus. The bottom of them is a castellated hole. That means that the via, the tube that brings the signal from the top to the bottom of the board is on the edge, and that makes them very solderable onto flat pads, which would be great for these, but I don't think I can go that small with the castellated holes. I'll have to look up what JLC allows me to do. Mankind can, of course, do that, but yeah. I could also do pins on the top and the bottom, but that would mean that I would need to run vias in order to run those pins. It's a weird kind of conundrum I've got here. I guess just running them on the bottom edge would be fine. Maybe I could peel them upwards a little bit so that I can see the solder interface. But yeah, let's test a couple of these and see how they did. and then maybe we can plug in the board and see if we can get keyboard software to run on it. Yes. So multimeter is going to be the first thing. And then we need my columns and rows so that I know which one is which. Does that mean I need Fusion on the computer? I think I do, in order to know which one ended up where. Which column ended up on which row. I didn't document it incredibly well, so let's open up Fusion, and hopefully I don't have it open on the other machine. Apparently all my subscriptions re-upped because I've done about 250,000 sponsored streams this and last month. All this stuff is Fusion. It's what I use in order to do my projects. I wonder what my head looks like underneath all this hair. That's what I've been debating with myself lately. Hey, what's up, Cyber Whiskey? Use some Cyber Whiskey. We're booting up Autodesk Fusion, which has gone full screen for some reason. Probably because in the other computer it is. Just kind of give it a little bit of breathing room. Just let it kind of do its thing for a while. Eventually, I assume we'll be booting into a program of some kind. We're going to take a look at the rows and columns where they ended up on the board, and we will test individual keys connectivity to that column or row. So we can go from the button all the way to the microcontroller and see if we've got, well, the button all the way to the mux, because it has to go through the mux, and we'll see whether or not we have continuity. Signal integrity extension has been added to my account. Learn more about this. What is signal integrity extension in Fusion? Oh, and then I have to follow it? That's okay. I don't think we're going to be using that because it's out of the realm of what the layman would be using were they to use. Oh my God, design extension will expire in 3 days. Simulation extension will expire in oh my God. All right, let's bring this back over here. I can ignore those. It'll come back up later. These are my plugins. Unlock more with Fusion Extras. Close. Okay, we're not using the extras. We're just using the PCB authoring stuff that's part of Fusion. I do like this program. I know a lot of people will bash it for various reasons. Hey, Tequin Dragon, how you doing? I'm saying that right? I don't know when I'm mispronouncing stuff. I'm too American and too uncultured. Okay, so we're looking at, I guess, no, I put it under stream. Personal is different. Personal is like the pins that I designed for the washing machine to fix it. That was the first and only super functional household print that I've ever had the opportunity to do. Our washing machine, the pins that hold the rollers on for the basket, you know, the basket in the washing machine that comes out, dishwasher, sorry. The basket in the dishwasher that comes out has little rollers on it. And so they started to break. What happened was the roller has its own little plastic shaft that's incorporated with the body of the thing that has the rollers on it, but then it has a pin that retains the roller. That's all it does, is it just retains the roller. So that pin broke off, and so the wheels started falling off of the washing machine, the dishwasher rather. And so what I did is looked up the glass temperature of PETG and the boiling point of water. They seem to be pretty compatible. PETG shouldn't be too stressed out by the heat cycle of the dishwasher. And lo and behold, it kind of isn't, although we've had one of them break. It's been like a year. But I designed a pin that was easily 3D printable and then printed it in gray, and it's been a 100% solution for that. I would think that there's a potential for bacteria to kind of build up in the ridges of the 3D print, but otherwise, it's pretty damn good. They've been doing their job of basically just holding these little wheels on. So I can rename these columns to be the columns that are represented in my drawing. And I think I kind of want to do that to make testing easier. Because I've got in my documentation, I've got this sort of master setup here where I can figure, well, I don't know what those arrows frickin' mean. Did I swap those or did I not? See, I don't know. Column 0, 1, 2, 3, 4, 5, 6, 7, and 8. 0 and 3. Is that because down here I'm combining them? No, this one is a combined drawing. So P6 and P7 are combined already. But column 7 is nothing. There's nothing on it because I rearranged things in order to null it out, I guess. So we don't know if that one's connected because it's a fake one. Huh. Well, spacebar is on column 0. And according to this, our column 0 is going to be coming into a different... Well, we know what pin it's on. Oh, but I didn't mark it down. Oh, I did over here. Wait a minute. Column 0 is on pin 1. And then column 0 has spacebar. So spacebar to pin 1. You've sunk my battleship. All right, so that's how we're going to do it. So we're looking at ohms, and we're gonna try this out. Here, let's do the advertising. There we go. All right, put E to ohms. And then pin 1, we're gonna trace back. Pin 1 goes down and up and around it. Oh God, into the super highway of pins. Look at this. This is the pin. Where does it go? Oh, I lost it already. Kind of looks like it's like this one. It's like in here. This gets split. Well, pin 1 definitely doesn't go up to the transistor. That can't be. I think our spacebar is like here. So we need to look at spacebar. That's a nice, easy one to find. Spacebar is, I gotta tilt it to get by the thing. So Windows, Alt, right Alt, Alt right, wait a minute. Space. And there's a before the diode and there's an after the diode. So where do we get it? I think we get it after the diode. I think the diode is supposed to be isolating. There's the cathode of the diode right there on the stripe. So right here's the cathode of the diode. Hope that ribbon is working out. We're about to test. So presumably on this pin here, okay, where are my arms supposed to go in this setup? I gotta retool the setup. Retool the setup. I need room for my arms. There you go. Now you guys can see the multimeter. And I can see the multimeter because I'm leaning forward. So let's see. Other side of the diode here. One is going to be the column, the other is going to be the... Wait, do I have this marked down? Hold on a sec. I have the circuit marked down. Yeah, so, okay, over here is my little note about that. So the column is going to be on the other side of the diode. So I was right. There are two diodes within you. Both are Schottky's. You're a Schottky diode. You're a dual Schottky diode. There are two diodes within you. They're juxtaposed. You're a dual Schottky diode. Okay, so we were correct. I was correct. I remembered my stuff because I've worked on this project way too much. And it's like, bother, why do you do this to yourself? You could just buy another keyboard. And yeah, time is money, and maybe $120 into another keyboard isn't that much of an expense for you guys. I'm a streamer. I make less than somebody flipping burgers. Way less actually until I pop off a little bit more, right? Every now and then there's like a shockingly large donation. That's really cool. But mostly like, you know, I don't make money. So buying a $120 keyboard, while it may seem like I am buying luxurious goods, I'm trying to make this stuff last. And so this circuit has been a partially it's a way for me to keep my subscription going to the expensive software, the $80 a month software that I use, and it's also stream content, and it's interesting and it's new. I missed the early episodes, but did you choose the Flexi board for mechanical reasons? The simple math of it was that I didn't want to do a lot of soldering. I didn't want to do a bunch of soldering, and so JLC PCB has Flexi PCB service for cheap. And so in order to get to the microcontroller pins, I can use a Flexi PCB, and unfortunately we've had to do weird stuff in order to get that to solder. Lessons learned, we can go back and make sure that that I properly do an edge finger setup. I need to look at the documentation for that. But the point is, I was able to make something that is solderable and takes all the pins of the microcontroller onto a PCB where it's not going to be a bunch of wires floating in space. I reproduced the exact same circuit because I just wanted to do a proof of concept of the whole thing. So we're still using the RP2040 on a module. Now the future update to this would be to put the RP2040 on the Flexi PCB, and then it would take up a lot less room, and it would still get on my goals of taking over the keyboard. If I just bought another keyboard, first of all, we wouldn't have this cool project to work on. Second of all, if I spilled something on that keyboard, it would just die. So moving the microcontroller up, as well as using a slightly more, I don't know, it's got a bigger health bar, the RP2040. So that's sort of the justification behind what we're doing. It's a lot of work. It was a lot of work doing this, and fascinatingly, I've learned a lot about computers, QMK, and I've learned a lot about how keyboards are laid out. It's been a little bit complicated, and we're here on the precipice of the end of the actual project. Reflecting on the amount of time it took is kind of ridiculous, but asking the streamer why they're doing something the way they're doing can also be interpreted as rude. I have to justify everything, you know? Sometimes it's just stream content. But anyway, that nobody asked, so why am I telling you? This pin right here should be a matter of ohms. Ugh. Hold on, I gotta tilt this and put this under camera. Everything's gotta look good. So this one right here should line up with the space bar here. 1 mega ohm. Why is it 1 mega ohm? Poke in a little bit harder. 1M, exactly 1M. What about the other side of it? No. How about the other pin? That's still a mega ohm. I mean, a mega ohm is a result. What's this one? One of these might be the space bar. Hold on. We're going to need to rearrange things a little bit in the software. Yeah, 1 mega ohm seems to be the internal resistance for the mux, which technically could be considered a result. Is this some iconic keyboard you're trying to modify? Am I getting this right? It's a code 10 keyless keyboard, which is, I think, a offshoot of the DOS keyboard. So, I mean, maybe you could consider it to be legendary, but I just like the code 10 keyless. It was a very expensive purchase for me, and so I want to keep it going. And so I've done quite a bit, because I'm capable of doing this kind of stuff, to the keyboard in order to keep it up and running. It's not looking good. It's not looking good here for a pin 1 connection. I don't see why anything would be wrong with pin 1. And measuring from the other side of the diode should net me the connection. I should have an ohms connection to one of these. That one's not connected here. This one. 1, 1, 1. What? Come on, man. Do your thing. All right, so I got to test it a little bit more locally. So if I go from pin 1 over here on this side of the pad, where are my hands? They're there. Make sure that I get through oxidation there and test these pins over here. Nope. Oh God, I can't even see what I'm doing. We might have a failure to communicate. Should have labeled these. I don't think. Hold on. Let's. Okay, here's what we can do. Vsauce Michael here. Where are your hands? I've stolen them. So we are on pin 1, C0. Highlight the trace. Go to the PCB file. This is the reason we've done so many sponsored streams. I can now trace this exactly to where it goes. And okay, we're supposed to be on this pin. Now we know. So now I can key in spooky chess. I don't think I watched that. I don't remember. Did I watch that one? I think I saw the Where Are Your Hands? Look where my hand was. Letting the days go by. Now we should be on an ohms basis with this pin right here. Higher angle into the thing. or not? What about the top part? Oh boy, this is tough because I can't really tell. If I go to this right here and I put some pressure on it, and then I go to pin 1 over here, that should be ohms. Let's just go right between the two and just see. I'll just poke in from the side. Oh, that almost looked like it. Damn it. Oh, I just scratched the pin. All right, so maybe ohming it out isn't really going to work out for us. Generally, this would be the next step here, is to ohm it out. One thing that I can test is power to ground. Just doing ohms between power and ground to make sure that we don't blow anything up. So power to ground, charging up. We've got capacitors on the line, but nothing is shorted. I'm not sure if it's not soldered. I'm not willing to say that yet. Those are both ground. Those will be ohms. So ground here to ground up here. Which one of y'all is ground here? Ooh, that's not good. Okay. What about power here? Are all of these terrible because of my soldering? 5 volts goes up here. Cool. Very cool. Very, very cool. 5 volts should be going to which pin? Let's look at the design. It's not looking good. It's not looking good for our wonderful cable hookup. Okay, it's the pin 2. VSys doesn't have anything on it. So V2 here to USB power here. Should not be in the order of mega ohms. Am I plugged into the right part of the probes? The probes are good, right? Probe to probe? Yeah, probe to probe works. So things are not looking good for power and ground. Although it does go through like a little filter, it should still, oh wait, no, here. We should still have like ohms on this. Damn it. All right, so we got to investigate the soldering. By all means, it looks like it's soldered. I mean, come on. How bad could it be? So I guess we're going to take tweezers. The tweezers might be a little sharp for the flexi PCB. That might be a little bit bad, but I'm going to try to sort of redo some of the solder here and maybe flatten this out a little bit more. I really could use something that'll flatten it, like one of these clay working tools. I think has a blunt end. Yeah, here we go. As long as this doesn't cut anything. Oh, but it's tilted to the side a little bit. But this is something that I could use to just press down the flat cable. As long as it doesn't cut it. I really don't want it to cut. And then try to go over. I need light. I need more light. This stuff, by the way, is very small. This is smaller than what I'm typically using on the stream. And it doesn't really give you any sort of a sign of what the scale is. You guys don't really get the luxury of seeing scale. Iron's on. Oh yeah, here's the other frustrating thing about this is that the overuse of solder has caused there to be bubbles in them. I can't quite get rid of some of the, does that look like a piece of wire in there? There's a piece of wire still. No, it's just excess solder. You do have the impression that everything is very, very small. That's good. Because, I don't know, using the magnification always makes it seem like things are a lot larger than they really are. Even for me, fellow piloting the soldering iron. I mean, by all means, that looks like it's soldered, so we should be getting continuity on it. Continuity? Yeah, see how the solder flows over when I bump up against it? It's like power is coming in on what one here? Hold on, let me check. The power pin is the one with the big trace. That's this one right here. So that one right there, is that soldered? Seems like it. See that? Got a little flow going on there. If a fingertip can cover 50 pins, it's flipping tiny. All right, let me get the big magnet off of the multimeter, because this thing has a metal backing for all the keys. This big magnet will latch onto it, and then it just really annoys me when everything starts moving. I didn't ask anybody to move. All right, so now from pin 1, power is really where you start. When you build a new circuit board and you kind of just get everything together like this, you start with power. Power is sort of your main concentration. So if I go to the other side of this thing, am I going to get 5 volts, or am I going to get 0? Or is that just a ground? That's just a ground. The power's going this way. I don't think it goes through any of this stuff. Well, my best interface is here, and I'm getting 1 mega ohm, which is kind of concerning. Putting a big ass magnet to hold the board down is a great idea. If you have a metal desk, I guess. 5 volts goes through all the way down, powers a bunch of stuff on its way, snakes its way through, goes all the way up, and then down on a smaller trace, oh boy, into this pin. That pin right there. So I can technically measure, and this should have continuity. Let's just check from here to here. Ohms. How about to this via? Okay, so we can use that via and not stress anybody out. So from that via, we should be directly connected to this pin. What the fuck? God damn it. EEL is steel plate. 2.2 mega ohms. I didn't expect this to fall apart so quickly. Why am I SOL already? What about this one? That one goes to 5 volts. That one to here. Here to here. 6 meg. That's not right. It's not right. It's just not right. That's just not right. That's just not, it's not, what in the, there to there, and we get 1 ohm, 1 little ohm, 1 happy little ohm. Right here, we get nothing. Good day, sir. Oh, that gets 0.4. Wait a minute. That right there gets 0.4. Does that mean that it is snapped right here? Is there a microscopic crack in our armor? 5 volts goes to this pin here. Camp myself right on that. Oh, wait, no. Moving it is so difficult. 5 volts there. To here. Ohms. To below. Ohms. To pin 1. Ohms. Okay, so we are actually connected. What about between the power pins of the Flexi PCB? I mean, we're testing it all. We're testing it all. So ground, poke it in a little bit on the solder there, to ground over here. Charging up a capacitor. Not really that much continuity. Okay, so ground comes in maybe on several pins, maybe not. Let's check the design. This is sort of the really nitty-gritty kind of stuff that makes this hobby, makes this discipline, makes electrical engineering suck. I think on the next board, instead of folding it like 180 degrees like I did, because right now we've got like our, here, let's get to a blank area. Right now we have our pin like this. And then on top of it, we've got the board that's folded over on itself. So it's like this, with the pin going around. And so our solder has to kind of flow out and around all of that in order to make a connection. I think what I need to do in the future is have the pin like this. Oh God. And have our board come down at 90 degrees, and then the fold can be like that. And so our pin on the fold, that. Go like this. And then it'll be down here as well as up here for a flow out. I think that would be a little bit better. Boots side of the board. Huh? Oh, iron on both sides of the board? No. I don't have that many irons. But yeah, I think the 90-degree angle would be the better one. Versus like that. Okay, so ground. Where is ground? Well, okay, so if I totally redesign it, I don't think I can do castellated holes. They're called castellated holes when you have a semi-hole on the edge of a board, like these little amogus, the little feetsies of the amogus, their little crotches. That is a castellated via. Castellated via, and it would require a little bit of run out on the side for the pad. I don't think I could have castellated vias that are this big on a flexi PCB. That's a stretch. That would be a great way to do it, but I don't think I can have it at that size. So I think we're stuck with these sort of connector style holes, but you need to have it 0.2 of a millimeter away from the edge, kind of the same way this ground plane is. My second mistake was putting a ground plane directly beneath all of these pins in order to make this connector a little bit more thick and less, flexible, I guess. It just makes it a little bit more thick, but the problem is having that ground plane there means that I can't cut the ends of these long pins that I put down. If I could cut it, then I could just put a ruler down and just slice off the end, and then my copper goes all the way up to the edge. Are there ZIF connectors that would work onto those pads? There's all kinds of stuff. Actually, the Raspberry Pi camera uses the kind of cable that you can just buy on Amazon, and it turns out to be the exact same pin pitch as this thing. So it's possible that I could solder down a Raspberry Pi style camera cable. There's a specific name for it. Short Lurker knows it. We talked about it on the Discord. But that would require 4 cables, and then I could, well, 6 cables. But then I could make a solid PCB for the whole thing. I wanted to make a flexi PCB, so that sort of steered some of our decisions. Okay, so the one that gets fat is ground. The one that gets fat. And then none of the other ones are ground. I could have sworn some of them were ground. Microcontroller is only getting 1 ground signal. Maybe that's why it dies so easily. So ground is going into the second pin on that top piece. So that would be that one right there. And so we can do either of these two over here are ground. And then I go up here, go to this one, and we get ohms. So then we go to this one up here, and we get ohms. Which should mean that unless I've captured ground somewhere, I don't think I did. That might be the one mistake of the board. That might be a design mistake, is not getting ground through and through. All right, so why? Let's trace it out. I don't know electrical engineering or much about this at all, but do they make a flat ribbon cable like that, which has a wire on both sides of the ribbon at the end? Imagine cutting the cable, then going back like 2 millimeters and removing the brown covering and exposing the wire. There might be stuff like that. There might be stuff like that. I'm not too aware of it though. The problem with this is that I can't put, like, my minimum via size is like this, so I can't really put that at the end of this. Technically, I could lineage back the ground. I could put a keep out area. And if the ground is lineaged back, then I can cut straight across this and make the pins exposed right on the edge. You risk, ripping up traces and stuff. FLETC PCBs have their own like special limitations and stuff that you got to be worried about. Okay, so the question is, ground comes in here, and it propagates all over here. It gets all over the place. That lower ground plane is actually doing a really good job because we get ground over here, and then we bring it over there. We get it over here through the blue plane. Blue plane is broken up here, but then the red plane brings it over here. We haven't gotten to our ground plane over there yet. Red plane there, blue plane here, blue plane here, blue plane here. Blue plane is still down here. We bring it up there. Blue plane does not get to, uh-oh. I don't think it gets over here. Is there a red plane bringing it over? So we're blue, we cut here. No blue there. I think the software would tell me about this. What is this doing here? Get out of here. Get out of my very limited amount of space that I have available to me. Why is this here? I can't collapse it? What the? Wait a minute. Oh, here. Go away. Nope, that's my up-down scroll. What the? Bring these all out. What are these doing here? I can't even minimize it. Hold on, let me make this full screen. Can I do anything with it there? No. Hold on a sec. Dock left, dock left, dock left, dock left, dock left. Whoop, what happened to that? Oh, I must have clicked something that minimized it. Dock left, dock left. Collapse dialog. There we are. Okay. We have, because my stream area is very limited, I have to do weird stuff with the software to get everybody to get along. Okay, so what I'm looking at is blue is the bottom layer, red is the top layer. And with all the traces that I've put down, it's a possibility that I might have violated a ground. I might have not continued a ground going from one end to the other. It would be nice if you could click on the areas and it would highlight them and you could see where they are. And that way you could check to see that you have ground continuity. I figured it would all come out in the wash. Just like a baby in the wash, it would all just kind of get thrown out the window. It seems like it kind of does though, but we're taking from this pin, we're going from ground here, we have a single trace coming out going to the ground plane. The first plane takes us all over the board, primarily to that bottom layer where I've got an even larger ground plane. So that's good. We have that connection. It's not cut off here. It rounds the bend, it gets to everything that it needs to get to. Then we keep going until we get to the capacitor that I tested, right? So we've got it jumping up under there, so it's still represented in all this stuff. It goes under the connector, it gets all the way to there. It does not cross this line, but it does when it goes up and over, thus grounding this little wing here. So that gets ground to everybody. Everybody is all grounded around here because it comes out from the upper part there. This trace doesn't quite cut it off. Neither does that or that. And then it comes over to here and things get a little bit more complicated. We have sort of this island, this long island that goes all the way up to here, but it still does make it through up and around this area. So all of this stuff is still grounded. It might go through a pinch point, which is why we use a lot of these vias, is kind of get rid of these pinch points for ground. But we still have ground here and on the bottom, and then this one over here, oh, but that cuts off. So ground is all the, and that cuts off too. Okay, all right. Where else? Ground out here, that, and that are all bringing ground into this. This one goes there, that one goes all around, but there's nothing bringing ground from here to here. However, it still is down here. Huh. And it doesn't, okay, here to here. No, still, that's an island. But it gets over to here. And then that gets it to this ground. So that's still there. I see a ground plane, but where are the ground wings? Hey, tippy white staff, everybody. I'll be here till Monday. Let's see. There's ground, and that gets over to there to that ground. So far, I'm seeing pretty good continuity with everybody. That goes there. That's on this big plane, so that one should be okay. This one goes to this little wing. Actually, I think the wing is going to it. X marks the spot. No, the spot is marked by the X. Yeah, and then that goes down to there. I'm just worried about orphaned. I'm worried about orphans almost constantly. Orphaned ground setups. But we found it out. We found it out for that one, right? Yeah, because it goes to the big guy. And the big guy's not cut off. No, the big guy's right over there. That goes all the way to our ground pin over here. This is a big bottleneck right there, but there's not much I can do about it. We'll find Waldo eventually. There's actually a search pattern. You go in kind of a spiral from the middle, like an anti-clockwise, no, clockwise spiral from the middle, and you'll eventually find Waldo. They found an optimal search pattern. I mean, so far as I can tell, ground is coming in from over here, so those all get grounds, and then this one gets it through that. Yeah, that one goes to the big guy, and that also goes there, and that can round the entire board. We got a really good ground plane on this thing. We should definitely be picking up our ground on the multimeter. So it's either that I'm poking into a flexible PCB, and so when I poke in, the flexible PCB is flexing, and then I don't get the probe pin to really make contact well. I don't know what else would be going on because we measured ground at both places. Maybe I can do this. It's specific to Waldo and the patterns of where Waldo is. Yeah, it's specific to how the author of the artist of the book, where they typically place Waldo. That should definitely be on ground. I got the 2 probe pins in. You got something to look at. Like that is on there. And this one is stuffed into there. There's no way that those should not be connecting to one another. We've got 200K. Don't metagame Where's Waldo? I didn't do it. They did it with AI. Or something. It's like a paper. I'm kind of really digging into these, and I don't understand why we're not getting continuity. Because if I go from ground here to ground here, we got ohms. We get signal. Main screen turn on. There. And so that's going up and around and then down to the bottom layer and then all the way up to any of these grounded pins. So really, technically, I should be getting ohms there. There's some other failing. It's my probes failing, not me. I don't understand that at all, unless somehow like this right here is broken or that right there is broken. And then this whole area doesn't get ground because that one pin is compromised just above where that solder is. Let's get closer. Does it tell us something specific about their personality? I don't know how far you want to stretch the intelligence of AI, but I don't think it's Sherlock Holmes. All right, let's put a big ring on this thing because we're going to get in real stinking close. We're going to get real stinky with this. We're going to get really close. Like, I need to use the flashlight to add light to this close. And then move this to the side, turn this off. We may need to go to the second PCB in order to get this to work. This makes the camera so heavy that it wobbles. Actually, I think I need the Z-axis for this. Why does it get so messy in the shop? Gee, I wonder. Prepare to get flashbanged. Oh, I guess it was darker than that. Bring this in. More and more light. Always more light for the closer you get. All right, there's some orange flexi PCB. Let the camera settle. And there is our Intrepid ground connection. Get closer to it. Those look rough. Hey, Copper. We are zoomed way the hell in. Oh, what is that? There is a piece of wire in there. Oh. Well, that answers that question. Second question, though, is that is there a break in the PCB right at the top there? Okay, if you could stop moving, let me get my arm, remove my arm from the actual thing. Try to tighten up the camera a little bit. Stop moving. Does that look like a break to you? I can't really tell. Kind of looks like a break. Lower this a little bit. No, oh, no, I bumped the whole thing. Screwed it all up. Let me get my flashlight. I'll get my flashlight. The one that I keep in my pocket. See if I can't shine a little light down on it. That really doesn't look like it's severed. It's hard to tell, but it really doesn't. But the continuity that we're getting between things is really where I question this. If there is a break in there, it is absolutely microscopic. And it would mean that we need to use the other one, the other board. I don't really see a break, although I do see a piece of wire sitting on the board. So let's move ourselves back out again. Let's zoom back out. Using the microscope at full magnification is tough. That's the thing I need to get rid of. I need to redesign this and maybe just machine out a little part that will mount the camera properly instead of whatever the hell's going on here. It would literally just be a piece of plate, although it would be actually a cube with a bolt going this way and then a screw, like a threaded on the top. Not hard to make. Of course, I don't have any of my aluminum anodizing stuff set up still, so it would be an unanodized piece of. Scrape off some flex PCB to test ohms. If it were on a harder surface, I could poke through the solder mask using my probe, but then you never quite know whether or not you've poked through the thing properly until you get conducting, until you get low ohms. And it could be that I'm just connected. It could just be that I'm not hitting. What I'm trying to do is rule out my own probes. Rule out the probing surface, rather. Because it seems, by all means, it seems like we got continuity. That's what happened with positive, is we got perfectly fine continuity on the two. I don't want to bring the soldering iron in and resolder it over and over again, but the fact of the matter is that it might be broken right at the seam, and there's very little way to tell. If I was really, really good, I could maybe cut just that top layer, but it's not as reliable as it is with it. Like if this were a proper solder mask, I know I could scrape it off of the copper, but this is a piece of like FR4. So if I cut that very carefully, there's no telling whether or not I actually cut through all of the layers and expose the, well, that would be exposing the ground to ground. That actually would be positive. Well, still, all kinds of weird stuff can happen. I feel like we do have continuity, and I'm just not testing it properly. Let me see. Let's find one that has foam right beneath it. Find a ground pin that has foam right beneath it. Foam. That would be this one here. And we'll push down. I'll twist a little bit. Give it a bunch of pressure. You guys can't see the meter. Hold on. Have to let chat in along the way. Gotta have you guys in tow. Bodging a random ground. I mean, I guess I could do that. There's like a scrape right here. What's that about? Okay, so that's the bottom piece. Then this one right here, we get ohms again. But then any other ground, where's that? Here. 300K. And then the one that I can really push down on up here. Really dig in. 400K. This is going to be a problem. All right, we got to go to the other. We got to go to the other one. Ruby's toe found the missing motherboard screw. Ow, my toe. All right, so I worked with this one too much. I should have refined my technique with a blank board. Not that I can't get all the parts off of this thing very easily. We'll have to do that now. But we'll get this board off, and I'll go to the alternative one, which has been sitting in the wings. It's the one that we built. Or is it the one that I built? I don't know. I built one, we built one. We went through all the steps, but this one has been unbended, whereas this one has been bent several times. That weakens the interface. It's just the same thing with wires and cables. So what we can do is put a tool behind the flat piece and then run the soldering iron, and it'll pop up without harming any of the traces. And then the entire board is a scrap. I could do bodge wires, but this would be faster than doing bodge wires, as we've learned. So put the tool under it like that, and then just go across. Maybe I should do this with a big one. I really don't want to pull up on it because I don't want it to sever any of the pads. Well, I mean, I guess it's okay if it damages this, but I don't want to damage the PCB. Yeah, I'm gonna get the big iron. I need like a theme song to play whenever I say that. Oh! The big iron on his tip. Big iron on his tip. Why are you buzzing? Motion at the front door. Oh my god. Man, I really wish I could afford that Ubiquiti stuff, because I could really clamp down the security on this place. I could have a key lock, a keypad lock on the front door. But I think just storing all the stuff locally, all of the camera records locally, instead of shipping it out to Jeff Bezos would be pretty nice. I'm going to add flux. I don't want to add like tons of solder. I guess that would help. But I think just wrestling intro. I think just a little bit of flux on this will help things flow a little better. We'll get them all, because I'm going to be getting them all anyway. I got to do something about the dog hair in here. Cleaning up the shop is going to happen tomorrow. Tomorrow we're going to have a nice little unique type of stream here for science and engineering. And that's cleaning up. Cleaning up is part of science and engineering, and I'll fight to the death about it. This place has gotten way too piled up on itself. And so if we do just a little bit of cleanup, it'll go a long way. And we got Julian coming in on Saturday, so we definitely need to clean up for him. No, not prenup. What are you talking about? Julian has a wonderful girlfriend who I've not met. I've actually not met her. I don't know. One day I will. Are you changing the organization of the shop? No, I don't have any ideas for that. I'm not going to change it. Well, things will just end up getting, first of all, putting everything away and clearing off surfaces. Oh, mom joke. Got him. I really need to make this able to be cut. That would make this much easier. But we'll do the 90-degree angle idea, and hopefully that'll pull everything together. It smells like burning circuit board. That's not a good smell to have. Burning fiberglass. I don't think I put down that much heat. This iron is at a normal temperature. Is it engineering and mathematics? It's science and technology is the category that I stream in. And so I'm just saying cleaning up is engineering. It's engineering a clean space. Oh wait, we've got 2 more to go. 2 more, and then I could peel it off with the sticky stuff. Go. I think it's just by virtue of the fact that I worked with it for too long, it severed the copper right at that seam. Flip it. Oh, flux is such a nasty smell. There we go. Now I'm basically taking over the microcontrollers from the old keyboard and making them, that's going to smell like burning hair. See that hair sitting there? And making them work with a PicoPi. And so in order to do that, I need to make an adapter board. And the adapter board comes as a result of JLC PCB having a flexible PCB sale. Well, their prices are also very reasonable for a flexible PCB. Flexi PCBs used to cost hundreds of dollars. It'd be like $400 to get a flexible PCB made. But JLC has them for like 20, for 5, and they sent me 6. So we built up this one, and then I ended up freaking killing it by overflexing the little ends, because the little ends, you can't have the pin on the end go all the way up to the edge. Has to be a little overlap for that solder mask to tape to on the edge of the board. Sorry, I'm hiccuping. So it needs to be 0.2 of a millimeter from that edge. And that ended up making it very difficult indeed to solder the way that I wanted it to solder. So I think what I need to do is take the pliers and clamp half of this and bend it only 90 degrees, and I have to bend it at this metal, not at the solder mask's intrusion on the area. That's like right here. Because the solder mask has to have an overlap on these pins. These are all requirements of JLC PCB. All right, so how do I get this thing off of here? Well, it is a ruined board, so I don't really need to go easy on it. Don't need to go easy on it, and I'll build up another one if it comes to that. You gotta be careful not to flex these too much, because it'll damage everything. You can see there, it's a little rough around the edges, but I'll live and learn. Now we know our limits. I need to remove solder from this, so I'm going to get my NVIDIA GeForce 4 back-end workspace. I cut this off of the back of a graphics card, but it's FR4 because it's got slight insulative properties as opposed to the heat sink that we previously were working on top of. That just means that my heat gets in there much more readily. So I will remove the solder from these pins. They're pre-tinned a little bit. Remove the solder from these, and then we need to bend them without breaking anything. And I have not bended these before. These have not been bent at all. So we'll use desoldering braid and the big iron, because that's our best bet for not ripping anything. And we're only going to bend these 90 degrees because the board will flex down to them. What is that? That removes most of it. Ugh, a lot of detritus around the area. All right, most of it gone. I guess my big problem with this board is that I didn't have like a jig to help me fold the cable over. I don't know how I'd make one. You got into like 3D printing plastic where it flexes in the middle or something. But getting that bend to be super even without damaging anything. And again, like you actually reinforce these pins when you design them in a real PCB. You'd put reinforcement on the back side of them. I could have done that and have a little overlap where I bend the pin over. That might have been the way to do it. Put just a little bit of reinforcement on the back. But then it'll encourage the stuff behind it to turn it like 90 degrees, and that's bad for the wire. So maybe that's not the solution. All right, and then over to, where is it? Over there. The Code 10 keyless had 2 microcontrollers. One was for factory reset and the LEDs. So you had this sort of like management microcontroller and then the keyboard's microcontroller. So the management microcontroller probably is the one that went bad. I don't know, because I spilled stuff on the keyboard and the whole thing stopped working. I couldn't reflash it. I couldn't do anything. So using the mechanical keyboard people's reflash of the Sonic's microcontroller wouldn't work for me because the controller is dead. Instead, I'm doing a full PicoPi takeover of the whole thing. All right, so grippy socks. How do we grip this and rip it 90 degrees? I think the best thing for me to do is to grip the whole thing at once and then just bend it 90 degrees with the pliers. And the pliers that I have are these. It's a good thing I had this second one ready to go. I have these. They're flat-nosed pliers. They're probably the best that I'm going to do. Do I have anything else? Hold on. Let me see. Let me just do a little tool check here and see if I've got anything that's going to better do the job of bending this thing up. Big stack of stuff right here. Move that out of the way. Got to get to the bottom drawer. This is, again, why I need to clean up. Stuff is just piled up everywhere. Weird tools. What do we got? Those are bent pliers. Those are ring pliers. These are wire strippers that are totally ineffective but very expensive. Cat 5 crimp coax strippers. A radiator fork. I bet my brother forgot he loaned that to me. No pliers in there. That's batteries. That's all old circuit boards. That's wrench stuff. No pliers in here. That's where pliers would be. None of these are, well, these are all tweezers. Anything flat in here? Nah. It's all tapered. All tapers, all the way down. I have neglected to bring a flathead screwdriver into the bathroom for a month. The toilet paper holder is broken, and I have forgotten to take with me a flathead screwdriver. And the stupid design of the toilet paper roll has every single function of it has a different type of fastener on it. It's a crime. It's crimes is what it is. It should be illegal. All right, none of that stuff's going to work. I think the big flat pliers are all I've got. So we'll stay in this view, come down here, and try to get a nice little 90 degree. And you get reminded on the regular, well, every time I sit down on the toilet and I realize that I'm living like a bum and my toilet paper dispenser's broken, that's really the reminder that I get. Like, oh, I'm living like a bum. Sorry, hold on, my fusion window is way too big for this. Smaller fusion window, come on, let's go. Okay, there we go. All right, we don't really need to see that. So the idea is that if I bend this 90 degrees, if you guys can see, I don't know, I've drawn over my own drawing. If I bend it 90 degrees, then the solder can get here and then a little bit right here, right? And so it'll look a little bit more like a pin that's been put down onto a pad. But it's not going to be exact, so it's going to be kind of like a lazy bend like that. But that would mean that this then goes back up to the PCB. And so that has a nice lazy bend there. And the pin has sort of a hard bend on a hard bend mid pin. So if it does break right here, it'll still have continuity up here. Right? That's the idea. And then maybe I can just use that to push down the board, push it down onto the PCB, and it'll do its job. Maybe. Let's give it a shot. And then if this fails, I'm simply going to redesign the whole thing. If this fails, I'm going to redesign the whole thing and start over and use an RP2040. Just, you know, chip on thing. Really what you're supposed to do is get this design to work 100%. You got to get it to work 100% absolutely, and then do all the corrections at once to the second PCB. But I don't know. This might be so cursed that I'm not able to do that. I guess I got to grip it like this. Grip it and rip it. Let's get this out of here because I'm going to be holding on to it. There's no grip that far out. Oh, look at that. You can see the gap. It doesn't actually grip there. Why don't you grip there? All right, there's a file. I need a machining file. I need a thing that I can hone this with. Wait, this is hardened. Can I get that open enough? Yes, I can. Just barely. All right, where's my grinder? It's over here. Covered in dust. Grindstone here. Flip it over to the, I don't know which one's which, but hopefully this can help us make it flatter. I'm not going to use oil. And that doesn't really help me there. I want to get the whole jaw in one thing, so I guess I've got to put this over the edge. This isn't exactly machinist kosher, but oh boy, that's loud. I ask all the machinists to look away. You know, I'm not a YouTube machinist. I may be on YouTube, but I'm not one of these fancy guys. So this is still going to be off by a lot, but we might get it to grip on the tip just a little bit more. Sorry about the squeaking. That is really nasty. I guess cleaning these would also be a way to make it. I haven't actually cleaned it. That's part of what this is doing. And as I go back and forth, of course, my hand is probably tilting like this. It's not exactly going to be doing the perfect job of this. I haven't used this thing in like 7 years. So eat my shorts. This thing was never going to live the exalted life of a proper grinding stone. It was always meant for this kind of thing. Well, it lightened up some areas of this that I think may be uneven. This is extremely high grit, and it's been sitting on the shelf for like a month. Let's get the other side nasty. Oh, it's 6,000. We should have started with 1,000. It looks like some of the high spots have been kind of linished off. If you're looking for proper tool usage, you've got the wrong channel. We'll see if that did anything. I've got all this like dust on my fingers. I mean, the pliers should be hardened, so it's not really going to do a lot. But it looks like it knocked off a bunch of like detritus. So let's see what that did. You know, no, that doesn't look any better. Ah, my hand's cramping up. That does not look any better. I would like it to actually grip at the tip. Grinding it is really the only way that I can get it to do that. It looks like I have to like linish a lot of it back. Although that tapers in a little bit. Yeah, you can see through it there. And then it grips here. And then it pops back out up here. So I would need to do a little bit more sort of heavy grinding on it in order to get it to really kind of grip right at the tip. I mean, this is why you buy Nipex, right? Nipex made their hardware with this exact thing in mind. I really don't want to use these on this circuit board, though. These will be really bad for it. But these are the miniature channel locks. They taper in on the jaw so that you can pick up a penny with them. That was like Snap-on's latest thing. It was, look, you can pick up a penny with them. I'm like, well, you can do that with any properly designed hardware. This, who made this? Pro America, USA. USA, America. Bald eagle flying. I could really use some work with like a grinder on this. I could definitely make that work properly. It would take a couple hours, and I'm not going to do that. I guess what I can do is kind of get a grip on it and bend it. I was using tweezers before, and the tweezers have a really good edge. But it was a little harder to control because the tweezers are bent to the side. So this is as wide as the tweezers that I have are. See, they're bent to the side, but they grip right at the tip. They're built properly. Right at the tip. And it opens up as you squeeze it a little bit. So I could attempt to do it again with these. I'm not sure if that's what caused the break in the bend before. You know, the one that I had previously. I could use a knife blade. Wait a minute. That might be small enough. It'll be a bit of a risk though, because if I slip with this, it's going to cut the FR4, or sorry, cut the this stuff, the Flexi PCB. But I could use this, put this down as like a limiter, and then get under it with the tweezers and bend up. I think that's my only good hope for this. So let's do it. Let's do it. That blade is going to be extremely sharp. I guess we'll work off of here. And then not these tweezers, because those are strange. I think I can use my normal tweezers to do this. Dull the blade on the grinder. There's no point in doing that. I'll put it on the knife actually when I'm done. I could also try to keep the blade side off of the board like that. Okay, so it's a little bit more extreme than it looks. It off just a little bit. Oh, look at that. That's perfect. That is perfect. Good work, Father. It's not perfect. That was not what I wanted. Shit. That was terrible. No, that was awful. I wanted more of the exposed. Oh, it bent right at the thing. It always does. Son of a bitch. That might have severed some of the connections. I got to bend it back down. That was absolutely the wrong distance. It looked great. It looked perfect. Oh, shit. All right, well, we're going to try again. I mean, how many connections are on the bottom piece there? There's a couple. There's a couple there that are important. Don't you clap for me. I failed. Yeah, that one is a complete failure. Twitch now detects if your browser tab is in focus. If not, it just keeps replaying ads till you focus. Then it lets the timer start going down again. What the fuck? That's pretty bad. Hey, Ryan Labs. I'm trying to bend the ends of these things without bending the, what do you call it? Without bending the solder mask edge connection. And I just failed pretty badly. That's how it should be, right? And that little bit was fighting it. I need to have a little bit of the pins still visible from the side. So I got to be careful about the next ones. Using a knife blade as a straight edge. Actually, my miniature ruler might be a better knife blade in this case. Yeah, this is probably a better idea. Why did I think knife? Why did I go to the violent option first? Oh, because it's so long that it's going to be unwieldy. Here, I can fix that. God, I'm working at my full extension here. Let's move this in so I can sit a little bit closer. That's better. So all the way up to the edge. Press down hard. Get under it with this. Might not be enough exposed. Maybe there. Ugh, come on. All right, that'll do it. You know, you need to bend it more than 90 to get a 90-degree bend, but as long as there's something there. Yeah, see, that one's good. That leaves a lot. I got to do it for the other two now. Welcome to my stream. This is what we do all day. Which ones? This one and this one. So we need just the smallest amount. Don't overdo it. Then we can come in. I wish I'd done it correctly on the first one because the first one's now going to be a little bit weird. I don't know whether or not that first one is going to have broken traces. It depends on how pliable this stuff is, how many bends you get. That's all I can do. It leaves you with less than a 90-degree bend, but this whole thing is falling off of the work surface. You know, like this. Yeah, there are components over here that are making the board, making the ruler stick up from the board. So this one might be the hardest one to do. Can't really get under it. Getting under the stuff without folding it is very difficult. I almost had it. Whew, okay, holding my breath, unholding my breath. This one might be too close. I think I overdid it. Too far, rather. Too high. This is much more controlled than the other ones, though. The other times I bent it, rather. They're all pretty good. I mean, this one is a little bit busted, but it's not really like a straight 90 degrees. It's a little bit softer of a bend, but that's fine because the pins will bend directly down and make contact, and then there'll be just sort of a little fade away that solder can fill. I can use this to give it a little bit of a bend, although I'm not sure. I don't want to push my luck. And because basically, well, that one's bent. Hold on, that one needs fixing. I don't know. So now we need to do these two over here. We got to do them all because I won't be able to position it like this when it's yeah, blah blah blah. I won't be able to position this when it's soldered in place. So let's try that again. But on these two are more surrounded by components. What happened there? Huh, hope that's okay. So this, right? Oh, the solder blobs on the other side are keeping me from pressing it down. Oh, maybe like this. But now the components on that side are keeping me from pressing it down. I don't want to put bends in. See how I just dented it right there? I don't want to put bends in it there. I just want to bend the very end. Make that a softer bend. Hopefully we don't see. Let's take a look. Hold on. How much did you pay for a thermal camera? The Lepton 3.0 thermal imaging sensor was $150 on eBay. And then the thermal webcam module from GroupGets was, I think, another $150 through them. It's a long time ago. Prices have probably gone down. Wait, what am I doing? I'm ruining it. Where's the end of this fucking thing? Oh yeah, it's still up there. Okay. No, I need to get it. This is a struggle. I wanted to make that a little bit harder of a bend, but I guess not. Ah, I've been bending my ruler. Oh, I don't like what it's doing up there. What in the fuck is going on? Hold on, I'm going to figure this out. Hang tight. Can't really see what's going on with that. This isn't bent. It's like not bent up. I unbended it. Yeah, and then it's got that like super soft bend. Terrible. What's going on there? Oh, it's awful. Oh, it's awful. I've messed up so bad. That could be a lot better. These turned out okay. These are shit. It's so bad. It's just because this component is so close, so I couldn't get my straight edge in here. And then these bubbles were keeping me from, laying it flat. I think they'll be functional, though. I think we'll be able to make them work. So now, I guess what I can do is use that little piece of tube that I had and give them a nice soft downward bend. Here it is. So that'll be just a rolling operation, I guess. How do I do that? Well, maybe I put it back here and then pick it up and just flatten it against this. Is that gonna work? No, it's unbending my stuff because I got caught. Damn it! Fucking thing sucks. Grab the end and roll it flat, maybe. This is not turning out as well as I thought it would. Mainly because my tweezers aren't exactly cut out for this. A little bit of persuasion, I guess it could be pushed down so that it's flat against the board. A little motivation there. And then I'll have to push in like that. Hopefully without severing these. That's what the whole point of having the mask go all the way up to them is. All right. Part of this relies on me being able to grab the whole thing with my tweezers evenly, and I'm having trouble with that because the tweezers taper inward. I go from over here. That's the idea anyway. Oh my God, this is so frustrating. Chat, I don't know if you can realize, if you have any sort of a sense about how frustrating this stuff is. Very clever to interface with the pins like this, but my inability to work with this stuff is getting to be an issue. If I just bend it with my hand like this. Actually, I feel way more in control doing it that way. Results maybe not as consistent, but just bending it with my hands seems to be somewhat of a solution here. Well, these are all lessons learned in terms of working with this stuff. All right, well, let's see how frustrating it is to solder. Make all these tools to help me out. None of them are actually useful. Let's clean that up first. Probably a good idea to just clean it up a little bit. Get rid of all the excess solder. The foam can stay because that's where everything's going. Iron needs power. Turn on. There you go. Let's get a fresh piece of desoldering braid so we're as nice as possible to our pins. And then get rid of all of this stuff. Desoldering braid is just relying on the capillary effect of having a bunch of copper wires next to each other and the fact that solder coats things, it pins them. So if I use a big iron and I get this real hot, and that's just for the betterment of our pins so that we're not accidentally soldering to a pin and then pulling it, and I put a lot of flux down and I get the whole braid hot, then the capillary effect will rid all of my pads of solder. And so everything is reset back to where it was before. We do this one too, and then we'll clean it with some orange flavored acetone. Goof off. I do wish that they were all this pin pitch, because this pin pitch is much easier to work with. Although I think the Sonics, sorry, they're both Sonics, but whoa, what the hell just came up with that? Oh, that's right. We were having trouble with those 2 pins, weren't we? But they're not used for anything. This one almost came up, so we got to be careful with it. How do you know it's actually orange flavored? Smell? It smells like it's orange flavor. I put it in my mouth. It's a goof off is what I'm talking about. All right, get all this stuff away. Hopefully the board survives this. I don't think those pins went anywhere. Let's just clean it first. Let me get a couple Q-tips, which are paper, which is mildly renewable. Get a couple of these. What the hell is he doing? Watching YouTube videos. He's a React streamer now. All right, so orange flavored acetone, a la goof off, or rather AKA goof off. He takes a big swig of it before every one of his streams. You can smell it on him. He's delicious. How's it going, Debbie? Oop. It's probably going to eat up the foam. Ah, we lost another pin. I guess my big soldering iron was a little bit hot for this thing. I don't know how good the stuff is all attached, but we've reworked this board a little bit too much for my own liking. I would rather not ruin this board. It'd be nice if it, survived this process. My precious keyboard. I should have hooked pin 1 up to ground. Didn't do that. My dog is getting a in and out today, huh? I'm getting a lot of door warnings. I just hit the weights and now I feel massive. I need to start doing that again. I used to spend 3 days a week. This was long before I started streaming. 3 days a week on the exercise bike, and I'm not looking good for not doing it. That's not good. It's not a good look. I need to get back into that. There's no way for me to lose this weight other than exercising a lot, because it hasn't happened yet. All right, so the idea behind what we're doing is that we have a bend in the end of the cable here. What it's really going to be like, though, is like, here's the board. It's going to be like this, right? That's sort of more or less what we have. So getting solder to both of these things, it's not going to be easy because I have to hold it down and even, but I think we'll be able to actually get like an interface there instead of it breaking at the seam like it did on the other one. But it's going to be kind of frustrating to get into position. All right, I'll line all this up. Short Lurker's idea was to use connectors on all these. But I don't want to bring connectors into this. Why is it not sticking? It's not staying put. There, that's close. So it's on 2 pieces of foam. All right, and those are, I think, just the right height. If I can get that to sit flat, see that bend is so bad. It's so bad. I wonder if I could get the knife in there and get a bit more of an edge. I got to do it without poking through the orange, though. The annoying orange. I don't think that's going to work, because there's not a good surface to hold it down. I don't think my tweezers are going to do it either. Maybe the pin tool, the pin gauge, that might do it. All right, that looks okay. If we can get these to solder, I mean, that's a big if, but we'll try. Let me get the small iron tip. We need something precise in this case because I'm going pin by pin and adding solder. And then after that, maybe I can drag it across and get a nice even look. I'm missing a soldering iron. Oh, there it is. It's way over here. Yeah, here's the shorter needle tip, not the longer needle tip. Longer needle tip is not that useful. So let's try this. This is the big sticking point. And remember, if we don't finish today, it's not looking good for that. If we don't finish today, then I'm shelving the project for another time. Yeah, we've just been working on this a lot. I need to prioritize other things. So get my solder over here. Place it down. As soon as the dog gets back inside, she starts barking at stuff. Jeez, the nerve of that little pooch. All right, let's see here. You screw in the plate so it stays in place. I don't know which plate you're talking. I don't know what you mean. Oh, I need to put vertical pressure on this. Hold on a sec. My hands are cramping. It's a diabetic thing. Yikes. That was a big one. All right, I'm going to remove a little solder and try again. Where is the desolder? There it is. Got it. I got it. Well, if things mechanically work out the way I want them to, then it shouldn't be hard to solder. But stuff is also very small. Very, very small. Sometimes breaks are good for projects. Helps you reset and come back with a fresh mind. That's true. That's true, but this keyboard stuff is not supposed to be that hard. It's mostly just a mechanical thing. Just like I'm mechanically hard. Right now. That is actually sticking in. Look at that. Beautiful. All right, so now I feel clear to add flux to the system. This isn't the best view for what we're doing, but it's I only have the 90-degree view from this microscope, so we can't get like a partial side view unless I lift half of the board up, in which case things become a little bit weird. Yeah, I'm actually several yaks deep right now in terms of projects. Like we did that whole day of doing the 3D scanner, which is something you should get, Demi. The CR scan. That thing's really good. We did the CR scanning day, and the thing works great, but I have to circle back and actually do something with that hardware, which is to scan the steering wheel for the steering wheel project. So I can do an airbag adapter. I do an airbag plate, rather. We haven't had a chance. I had to shelve the project for a bit because I've got other stuff, several yaks deep. 3D printer, get. You need life-size human skulls. It's always something with you, Demi. Removing solder from these is very difficult. I need a lot of solder to make a nice blob so that the two can mate up together, but then I need to get rid of that little bit of solder, a little bit of excess in there. I kind of can't. QMK 9 is released, I guess. What? What's KiCad? I don't use KiCad. This is done in Fusion 360. They give me a free copy if I advertise them every now and then. The Braid doesn't really like to work with the tiny iron. Jeez, I get it, like it just doesn't. You think they actually like made the CAD program kind of intuitive? That's kind of impossible for any CAD program. None of them are really terribly intuitive. All right, so we can take a look at the side and see if that actually did anything. Get my light over here. It's actually kind of really difficult to take a look at the side. It looks awful. It does look like some of them tried to solder. Others no. So I've got to kind of work on that. What if I did... hold on a second. I got an idea. So I put the Z-axis under this part. This is probably the only one that we're going to be able to do like this, though. Yeah, see, like that. And I solder it like this. See, now I can see that it's kind of a broken interface between the two. You got two of the pins soldered, but the rest of them are sort of in the lurch there. I guess to get it soldered, I got to kind of go way back to where the pin is and come forward from there. I can do it much better this way. I'm going to need some flux in there. Flux, where did you go? You stupid flux. Oh, there it is. Back where it probably gained more dog hairs than not. No, this wouldn't work with the soldering oven. This is so these flat cables need to interface to where the chip was, and the chip, it's just the way I designed this. I'm going to redesign it, and it'll be much easier to work with. I'll put pins on both sides and only use the bottom pins, and that way I'll be able to actually get to all of the pads that I need to get to. But with the pads on the top end of the board, I couldn't put the pins up at the edge of the board. And so I was unable to make a solder bridge from the edges of these flat cables. So this is just a one way to make the connection instead of the way I wanted it to be. Oh, that bridge is very aggravating. Come on, man. I'm gonna walk it over here. So it either bridges to the pin next to it, or this is the problem, is they want to bridge on the widest spot. Like, I think this technique works. Nope. Fuck. Come on. Stupid bastard. Give me this. No. 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 Ah, that almost got it. Get out of there. Jeez. It refuses to like wick onto the iron, so it's staying down there as like a big bubble. Also, I can barely see what I'm doing. I need to get closer. It's like a big blob to me. I'm just not, my head's not in the game. Well, yeah, you'd be out $150 on a new keyboard, and I'm not willing to spend that money on another keyboard. I already have a lot of flux on it. Stop shaking. Jeez. Yeah, look at all the flux that's down there. Being able to see helps. That's very frustrating. Okay, so maybe lifting up is the way to go. I'm gonna have to remove a little solder there. Go this way. Come on, come with me. This way, this way, this way, this way, this way. It's not moving with the solder, it's staying put. All right, desolder braid. Now that there's a lot more flux in the area. You know, the boards were like 20 bucks, so maybe I should just redesign it. Come on. Lift and separate. There you go. Ow! Hit my finger with the braid. So as predicted, this is not sitting as flat as it could, which makes soldering it a little bit more challenging. Just because of my inability to actually bend this stuff at 90 degrees. No, no, no. Why are you still doing this to me? Oh my God, I'm so mad. I'm so mad. I'm so mad. It's the width of the pins encourages it to, instead of going to the bridge, it bridges the two pins. This is how I end up breaking it, making it non-functional. I definitely need a redesign on this. And the tiny soldering blade, a tiny iron tip, means I'm unable to get a lot of heat into the solder braid. So it makes it hard to fix. What the fuck? Where's it all coming from? Look, I didn't add any solder, but I'm swimming in the fucking stuff. What up, Michael? This is me working on Game Boys. It's like, who's cursed me? Somebody gave me a soldering curse. You shall be fated to have too much solder on everything. Ooh, ha, 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 ha. Clean the tip. It really should look more smooth than this. Hope I didn't do it. Oh, am I having a network issue? Or is it a Twitch issue? It's not a Twitch issue. My bitrate's fine. Oh, I just hear people saying refresh in the chat. There it goes. Now it could actually just be connecting just fine. It's just below. I can't see in the little bend. So I don't know if I need to totally load it up like these two are. That's why I wanted to do the point-to-point testing, which I guess we'll just do on this. It looks like crap because it's covered in flux. You guys are constantly bitching about me about using flux. And when I do, you bitch about it looking like shit. Well, everybody's being very kind. But everything looks like crap and you can't get a good inspection on your joints when it's covered in flux. So let's just see what we got here. What's the role of flux? People have been memeing it lately. Flux keeps oxygen from getting into the solder joint. And so while you're applying heat and you're applying solder, that flux is going to keep things, well, it keeps oxygen from getting in and it holds heat in an area so that you're not wicking away your heat on anything but the copper. And so having that heat localized and having the oxygen being kept out, your joints will be more smooth as a result. Will be a little bit more bulbous and smooth, and the iron will have less work to heat things up. You can use the pretty flux instead. There is none. Okay, let's look at that side of the chip and see what's connected there. Yeah, when you do like the artistic or the stuff that looks good, you cover everything in flux, and it's just not a good idea. I don't like having that much chemical around. And what I'm doing right now is rather unorthodox. We have a flat cable. Like if you look at the side view, we have a, gotta get my mouse cable out of the way. We have a flat cable that's going on to, like there's our board. Our flat cable is going like this, and then it curls up. And so it's hard to see with the human eye. Let me draw an eyeball. It's hard to see that little bit of solder that's making a connection to the pad. I'm not too worried about cleaning it. Yeah, cleaning is easy. You just use orange flavored acetone. We call it goof off. So one of these pins, let's say this one, let's highlight. I really don't want to analyze signal. Let's just choose one of these guys. This would be one of the rows. So let's do row 5. Highlight that, go back in here. Oh, sort of close, although I am confident this one's probably fine. So the rows are all the way up here on this one. So we can use these in order to test these. So row 5, and I'm counting from 0. Yes. So 0 to row 5. Oops. We cross-reference row 5. Although I just did them in order here, so that might not be the one that I'm looking for. Whatever one is connected to P3, no, that's not right. Pin 2.5 would be, oh yeah, this is on this document, still here. .5, row 5. Okay, it's still row 5. Row 5, print screen, right alt, scroll lock, function, left alt. Oh, but we're looking at row 5, sorry. Row 5. Left Windows button, Shift L, delete, F7, tab, caps lock. Which one is closest to the area that we're looking for? Left bracket, maybe? Maybe left bracket. The row is on the other side of the button. Yeah, the goof off just pretty much wipes it away immediately. Goof off and a Q-tip. So we're kind of close up right now, but I'm looking for like F7. Where's F7? F7 is over here. There's F7. I'm glad they labeled this thing. That's the diode. So on that side of the diode, we have the column, but we're looking for the row. The row's here. So I need to connect there, and then I need to connect to wherever 5 goes. 5 goes to this pin right here. So I'm going to go from this pin, third one in. I'm going to measure ohms. Hopefully this works. God, this is tough. I'm not making a keyboard. I'm repairing a keyboard by putting in a microcontroller that's not going to blow up the very second it sees moisture. It is not connected. There's something there. About this one? About this one? Quite. Ugh, damn it. And then if I go. Oh, that looks so bad. Is it that one or is it the second? It might be the second one. Damn it. Oh, the probe peeled off part of the... Oh, fuck's sake. All right, this is cursed. I think I've ruined the keyboard. That means this whole project is dead. Fantastic. Well done, Bother. My probing just then, I may have broken the connection of that top pin. This keyboard will be safe for the bathtub. Not quite, but I mean, it will survive my shenanigans. R3. That's up here. So R3 up there, and then R3, row 3 rather. Row 3, pin 37. Row 3, enter MV control, right control. Right control to that one, which is this trace that runs up here, is this top one that I just poked at and tilted the entire pin over. Tilted the whole pin. So right control is right here. This part of the board up here. If you guys can't see what I'm doing. You can see the multimeter. You don't see me poking in. I'll do that so you can see. Oh, did my camera freeze? That's fucked. God damn it. That messes up my whole system, and now I'm very mad. I think overall this is just completely cursed. I think there's a lot of cursed stuff going on. All right, let's unplug you. This is a very bad connector. It's very, very bad. It kind of wobbles, and I was going to fix it. We started to fix it, and then my my digital readout on the mill broke. So now this is going to kill the... All right, so we go to this, and then I go to the microscope, disconnect, reconnect. That looks okay, although it's a little, you can see little gritty stuff flying around. Well, I did it one wire at a time from the other design. This is supposed to be the whole thing at once. Guys, you got to understand that I've been doing this for a long time, this keyboard project. And this is supposed to be our foyer, sort of our first look at doing a flexible PCB setup. And in working and reworking this board over and over again, I guess I probably put too much heat into the pads. And what can happen is your pads, your copper, can stop sticking to the... Yeah, this is... What's going on here? Micro procedure, come on. Oh, it's not having an effect on the board. I've got to quit Streamlabs and open it up again. Quit Stream Deck. And start it up again. DRYTS. Stream Deck. Open up Stream Deck again, wait for that to boot up. Where the hell is it? There it goes. Stream Deck is booted. All right, setup. Uh-oh. Come on. Come on back to me. Setup. Oh, went too far. Micro procedure. There it goes. All right, now I'll probably not have the trails that I had before. Yeah, that's a little bit easier to see. Okay, so this project is the second keyboard like this that I have. The first one is still being used with the whole setup on it. So it's got the whole entire setup going for it. This is what we're going to program onto this board. This board was created to recreate that setup, but with a flexible PCB. And so I'm having a little bit of trouble soldering this thing. It seems to be going all right. It's just the more I work with this board, the less the actual pins are going to be adhered to the FR4. And you eventually run into a problem where they sort of kind of leave. They kind of just leave. And also my whole space is a huge mess. So what I would like to do is a cleanup day tomorrow. We're not going to work on this tomorrow. See, that one seemed to work out all right. Let's get a little less claustrophobic here. Just a little. Oh no, it doesn't focus if I do that. I have to be in this far. Okay. So we're in this far. Got that little thing there. Is that pushed down all the way? Check with the pin tool by coming up from behind. See, it's coming down at a 90-degree angle. I need it to be folded, and I guess maybe we don't have the space for that. So I think part of the problem over here is that it's not folded. Like the pins aren't folded over properly, and so I'm trying to bridge that 2mm gap. Oh, I'm so frustrated right now. I'm about to start screaming. I am mad. You guys don't know me to get mad at anything, but I'm starting to get a little mad at my own setup. I cannot get it to focus on this. Okay, taller pad over here. One sec. The good part is the track is still connected. The pad is bonded to the pin. Demi just subbed saying it's time. What, glue gun time? It might be time to just call this project fucked and just move on with my life. Yeah, sometimes the pad lets go, but it's still connected with copper, which is kind of what I'm relying on here. This is way too much of an angle. No, I did not put the connectors on the underside. That's my first mistake. I still can't lift this up a little bit. We're just going to view it from further away. I have to prop this on its side so that we get a good side view of the connection that we're making. There we are. What I tried to do is use a tool to bend the very end of the cable, but because of the scale of everything, I'm having a lot of trouble getting a full 90-degree bend in that. And the previous board, which was all built up and ready to go, the previous board, having bent these fully around themselves, somehow damaged the connection up here. So up here, where the solder mask comes in, that was weakened, and then it cracked. And so my ground didn't have any connection to the rest of the circuit. Those are the problems that we're having with this thing so far. It's all the big names in working with flexible PCBs. I'm having all of my favorite problems. Damn it. Fucking needle nose. Needle dick. Soldering piece of shit. Part of the whole purpose of what I'm doing here is to learn that. I believe that was the ground pin that I just did, and that went really well. Oh, it didn't solder though. It still didn't solder at all. Is that attached? Not really. I don't want to poke it with a hot iron. There's also a big shadow that's keeping me from seeing what I'm doing. I gotta angle this with my light. Hold on. Let's get the multimeter out of there. Yeah, this is I'm very frustrated right now. And I didn't want to spend this much time on it. It should have been way easier to solder. Next time, I definitely put the pads under the cable, and that way it could just lay flat. I could just hold it down with a pair of tweezers. Hold it down with a pair of tweezers and then just add the heat and the solder to it, and it'll just solder right on. It'd be totally easy to do. In addition to that, I might actually have to repair some of the traces on this thing after this attempt. Where's my arm supposed to go? Giant fucking light? Huh? Did you think about that? Did you think about where my arm is supposed to be in this entire... Okay, lift this up a little bit. And then the stand gets in the way of the stuff that I have under the desk that I shouldn't even have there because I'm so disorganized. Okay, we're in the microscope only view. That's not the right view. You guys should be getting more information than this. There we go. Now you can see everything that's going on. Me struggling with the goddamn setup all the time. casting a shadow almost immediately. This is really easy to see what I'm doing. Yeah, it's great. God damn it. No, I can't see with my shadow. Okay, let's see. What can I do about that? I'll go down at a higher angle. Why is it casting such a huge freaking shadow? Zooming in to this level is it's just, I gotta tell you guys, it's not easy. It's not easy. Everything you do is more clumsy. Everything you do is a little bit off. Can't quite have the same control of your muscles. In my case, it's just not there. No, we can't do this. I've got to redesign. That really needs to curl in more. The alternative is just cutting it, but I don't know if there's a ground plane beneath it, so is it off by so much? Probably just to get my tweezers in there, it pushed it out to the side. Come on. Come on. Patch. My iron's off. God damn it. Turn on, stupid iron. Hey, long dog. This ended up going a little sideways. Boy, it would have been nice if I could see anything that I was doing. Too small to tape. I have the ability to work very small, but some things just don't scale down that far. And if I could, I guess put down a piece of Captain tape and then sneak it under and then tape it down. Like this is what they all should have been, just like that. It's the 90-degree bend in the end of the little pins that has really thrown me off. That's looking a lot better than it was. Sure would be nice if I could get light in here. I need one of those fiber optic lights, those fiber optic illuminators. Those are real nice doing stuff like this. I had one at the FBI shop. It was very nice. Actually, at the research shop, I should look up fiber optic lights. I used to have one. I don't know what happened to it. I'll install it. I'm working in a shadow, which makes it even more difficult to figure out what if I'm doing anything wrong. I'll get right on that. Now, I can't afford a scientific fiber optic illuminator. Those things are expensive. They charge out the wazoo for those things because they're scientific equipment. See if we can get this going. Let's try to pull it over. Pull over. Well, it gets us there, a little bit closer. All right, so too much solder here. I don't want to ruin my traces, my beautiful traces on the PCB, but might be an inevitability. Just working, we've been working over these pads way too much. PCB using React, and he designed a keyboard with Pico. I don't think he printed it yet. What is React? What do you mean? What that is? This is an ongoing project. I Picoed my code 10 keyless with wires, and now I'm doing it with, this is lifting, this pad is toast. That's not good. This is me trying to do a flexible PCB with the Pico module, and then later on, I guess what I can do is just do an RP2040 on the Flexi PCB. I mean, that might be connected. We're just trying to get this, like, no matter what, we're trying to get this thing running. What the fuck happened over there? It kind of looks like some of them are connected, some of them aren't. We kind of expected this to be the outcome anyway, but would have been nice. I guess what I could do is, oh, a JavaScript framework. Weird. We're using QMK for the software. I mean, QMK is not easy, but it's not hard. A lot of people in my chat have used it to good effect. Okay, so my inclination here is to stop before I ruin this too much, because my $100-ish, $120 frame is going to be ruined if I keep going because of the damage that's being done to these pads every time I try to desolder. We can do a couple continuity checks and see if this has come to fruition a little bit better than its buddy over there. You can post the link. That's totally allowed. And the reality of it is that I should have had the pins on the other side, because then we could just lay these down on top and hit it with the solder, and then they'll just like instantly clap together like my ass cheeks. But let's do a ground test. Let's see if we've got ground and power continuity, just like before. This time we'll zoom out a little bit. My whole mantra of getting it absolutely working the first time you get a PCB has fallen completely apart on this project. This one is the disproving the rule. Disproving the rule. Oh no. Oh no. Is Timmy's daughter gonna start giving emotes again? Very cute. Although I don't think she'd do the hip thrusting one. Sark. GTA. Did Sark used to play GTA? I mean, I guess most of his emotes are GTA. GTA's been around just about as long as Sark has. 10,000 years of streaming. What's up, Niano? This has not been going well. Where's my arm supposed to be? Where am I? Think about the human. I'm the human in this shop. I need to be able to move. Why is everything so goddamn close? I'm getting so mad. I'm getting very mad. I'm very frustrated at the failure of today. And to be fair, it's all on me. It's all these are my failings. I own these. So power here to power here. Okay. 0.7 mega ohms is not exactly a connection. Really drilling it in there. Yeah, 0.733. I'm going to need to redesign this thing. We're going to have to start from scratch. So that's ground, and then any of these are ground. So hit this thing right here. And actually designing it from scratch means that I can get rid of the Maxim parts. If I flip the layer that my chip is on, then none of this drama from today should be a thing. All I do is bend it down and solder it flat to flat, and it'll be perfectly all right. But notice how I'm getting 1 point something mega ohms to where ground should be. Like over here, ground. Bada bing. Boom, ground. That should be ground. I'm getting nothing. Good day to you, sir. Oh, also I probably should put something under that. Ground here to ground here, easy 0.8 ohms, right? Ground here to ground this right here, OL. Ground there to ground here, easy 1.3 ohms. JLC PCB is very cheap for these flexible PCBs. Now this is my first design. I'm out like 50 bucks for the 6 of the boards that they sent. They should have sent 5, they sent 6. I don't know why they did an extra one, but you don't want them all. It's 50 bucks of entertainment, right? So I'm out like a delivery cheeseburger these days. Delivery can get very expensive. Damn it. So all of my intentions here have just gone up in flames. All that's left is to safely get this thing off of the board, probably deconstruct these so I can turn those 2 modules back into something. 10 coffees I measure with coffee. Yeah. There's usually an extra. I didn't know this about JLC. I used to use Seed Studio, and I still love Seed Studio. I think they make extremely professional boards. But we were trying out JLC, and also because their flexible PCBs are very, very cheap. They're not cheap. They're very inexpensive. They're very inexpensive. 10 usually becomes an order of 12. Interesting. Well, let's get this thing off here safely so I don't ruin all the pads. What's the kindest way that I can remove it? I mean, I guess no. Hot air is actually, well, yeah, I gotta use hot air, and I have to make sure that everything's molten at the same time. What a bunch of piss. I could have definitely gotten this working if I had put the pads on the right side. But the next iteration of this is to go directly to the RP2040, and I'll just move it out this way. So instead of this big U shape that I've got going on, this sort of weird U, I don't need any of this stuff. All I need is a chip that's this big, so I can put it over here. Maybe I could get it in the middle if I'm lucky. I don't think that's really going to be the reality of it. I cannot go up this way, so I can go over here. I could put it down here, but then putting it lower than the microcontroller was last time, I would hope that this thing does well with moisture, but up here I know it's super safe. I definitely don't want the board to be this size. These 3 chips are the reason, and using the modules, the reason this is so big. But it can be reduced to just an RP2040, maybe up here, put the RP2040. That means a lot of the traces are going to have to kind of snake their way around. And that can induce interference, that can introduce interference into the whole thing. The other part of it is that all of the traces are going to be on the underside of the board, but they all need to come up to the upper side of the board if I'm doing the pads the way that I want to. Which, as far as what we tested today, is the only way to do it, is to have the pads underneath the cable thing so that it just does a nice, easy bend down to where it is on the board. I think they have assembly service, but I don't need assembly. So what's going on here? Is this installed? Yeah, there's a pin there. It didn't get soldered fully. Code, what are you doing here? What are you doing, Code Keyboards? This is a Code keyboard with Cherry MX clears. Code 10 keyless, I should say, because it doesn't have the 10 keys. Where will they come up with all this terminology? It's amazing. Safely remove this. I guess I'm going to use hot air. Why are my shadows so hard today? I don't understand. Usually we don't have this much trouble with shadows, and I think it's because when I'm working on stuff, it's lifted a little further up from the bench. I mean, I could get a ring light for the microscope, but I don't want to make the microscope any heavier than it has to be. A ring light would probably help out with some of these things a lot. I've gotten by without the ring light for many, many centuries, though. I got my 3 points of light that discourage shadow, and usually we work at the top of a miniature vise, which is probably why I'm having struggles with this, because it's a little lower than the vise. See, that just removes itself with no issue at all. I gotta be careful with this one because this is the one with the lifted pad. Okay, that was easy. All right, I'm gonna get all these parts off of here. Oh, I think I just removed the adhesive from that stuff. Oh well, don't care. I need to get my Max 309s back because those are important. I'll get the Max 309s off of here and then... Ugh. We learned a lot of lessons. Maybe that's the cost of the stream today. Instead of adding up the cost of my derelict fucking keyboard, we consider... Maybe it was the enemies that we made along the way. Maybe the friends of the friends we made along the way. The hard part was that I designed it wrong. That's really the bottom line. The pads of that component I'll need to move in the layers to be on the lower layers. And that'll fix both of those. And then we can put into CAD the design and try to have a redux of it. The version 2. And this time it'll just be the RP2040 and an EEPROM. And then I don't need all of the Max 309s. I still do need the transistors, I guess, to run the LEDs. Because the RP2040 can't sync the large amounts of current that they seem to expect you to sync for those. Photos. We can be a little bit more haphazard with the tape down. As I recycle all these parts. Where's the Max 309 bin? I want to make sure they get in the bin right away. NeonoCat! Hey, NeonoCat, thank you so much for the 17 months. Hey, I really appreciate that. Today's been a little bit frustrating, but, you know, going through things and being a little bit bullheaded about everything and just kind of running into all of the china in the bull shop, perhaps was a bad approach. But now we have lessons learned for our next version, and your contribution to this stream is directly responsible for my idiocy. Now, for my ability to do things like this. These are very affordable. They're still a little bit more expensive than a regular PCB, which is fine. $20 is $20. I'll do whatever it takes. That's not the first time I've said that. Where are you, Max 309? These Maxim chips are relatively old in terms of like analog muxes, but they're really good. They were used in instrument. They were going to be used in instrumentation, optical instrumentation for brain monitoring. And I ended up with a whole stack of 308s, 309s, and 333s. I don't know if anybody's really using these. 309, here we go. 308s, rather. The 308s are the ones that I've used up. 8s are an 8-channel single mux. 309s are 2 4-channel muxes. I'll do whatever it tacos. Sure. Whatever kinds of... As long as it leads to tacos, I'm good with it. Okay, so get all this stuff out of the way. We're going to need just tweezers, and I need the plastic to be out of there. So I'm going to move my bins and go back over to here, and we go to the chips that I want to recycle. The transistors, the resistors, and the capacitors are all completely disposable. There is no reason to save them because I have them by, you know, the pound, and you order them by the pound. So if I stretch the jaws out, they'll hold on to the chip. So I can tell when it's... I mean, the thing is, like, I could just literally rip these out of here with my hands and then peel the pads off with a soldering iron. But I guess I don't want to... I don't want to bend the pins. Ouch. All of the hot air is going towards my fingers. Longer tweezers might be good. You know, this might be a scenario where I want longer tweezers because all the hot air is going directly towards my hand. Air from a different angle might help. Sort of. Oh my God, that's hot. Okay, maybe I can just do it from a high angle like this. That'll be a little easier on me. The thing about the flexible PCB is that, unlike FR4, it gets hot immediately. So hot air is actually a really effective way to mess with it. I think it does okay. I don't know about the extreme heat of hot air. I guess we're finding out the only way we can. There we go. That was like real easy. That was pretty easy to do. Try the other one. We got 6 of these to free. It doesn't appear to be warping the board at all. I've just got Captain tape on either end. And since we don't have like a cool FR4, look, that pin wasn't soldered. We don't have like a cool FR4 substrate. It comes right up. We do have an FR4 substrate in the board that I've taped this to, but and actually it's got a giant ground plane on the board I've taped it to. There's a couple more pins that weren't soldered. Huh. Interesting. I don't think I'll be able to get this whole thing free at once. That's not something that can happen. It's just got too many pins. Yeah, that's not happening. I shouldn't keep going. But what if it works? Oh no. My hubris. Come on, hubris. Yeah, my hubris. Didn't lose any components on it. This stuff heats up so quickly, I guess it didn't threaten the board components at all. It's because this is so thin and easy to heat up. Oh, and I guess these let go too? That's weird. Did we actually solder to them? We did. So my little test point connectors actually worked. I don't think it was any kind of skill on my part because I basically just yanked it up. It just basically yanked up. I think it's just the heat sinking abilities of the FR4 versus the... it's so disappointing to see the death of something that I thought would definitely work. I definitely thought this crap would work. Oh yeah, the little heat discrepancy between those two. That might be. Disassembly number 2. This thing is still hot as hell. I'll let this cool off before we rage quit stream. Tomorrow is cleanup day. We're gonna have the burn the subs camera. I'm gonna be sitting over on the floor over there. We're gonna go through the project boxes. Ow, this thing is still hot as hell. Go through the old project boxes and throw stuff away. Lower my project carbon footprint, I guess. Just hold that down so I can get heat into the chips. pico pies, probably still molten hot. That's not that bad. This thing has good heat dissipation for what it is. That's just a piece of solder. Okay. All right, so microscope. I'm saving these because they are my last 6 Max 308s. And the Max 308 may come in handy when building synthesizer stuff. If I do custom one-offs, this thing works at plus minus, what, 3 volts to 15, 20? No. It works in the plus minus 10 volts that synthesizers work in. So if I want to mux a signal, I could use one of these. You know, I could build something that counts based on voltage, send it into the one input of this thing, and then have it just divvy out whatever signal's coming in. You can do all kinds of weird gating with that. It could be a type of sequencing even. That one, whoa. Did that make it in, or it like jumped? And then my garbage can made a thud noise for some reason. All kinds of weird noises. I guess it's really cold outside. I'm gonna go find out in just a minute here. All right. Yeah, see how easy that was? You just get stuff a little warm and then everything is popping off of the board. That's why I was so confident in removing this. The Pico Pi. And if you separate it just a little bit from the base plate, it actually helps. Look at that, beautiful. You can go along here. Uh-oh, no, it just broke off. When it breaks off like that, you lose your ability to peel it up sequentially. I can still get it. You guys need a different view. Like this. Damn it! That doesn't help. Forceps. Hold on, gotta put this down. Come on. Damn it. There we go. Gives me a little bit of drawing ability. Oh, come on. Everything about this board is frustrating. I hate it. Everything in it is wrong. It's all cursed. Jeez. Okay, separated. Now, did we get solder on those pads? Yeah, it looks all right. D minus and D plus have a little bit of solder on them. Ground has a little bit of solder on it. And the other ones, I think, that one does not have a lot of solder on it. Looks like I didn't get the ground solder, but we have 10,000 grounds all over this thing. Ow! Okay, it's a little warm. Well, I'm disappointed. Hope you guys are having fun. That was going to be 2 Pico Pis and 2 keyboards that would have been permanently working, and I wouldn't have had to think about any of it. But now I've got to go back to the design and redo it with the intent of using just the RP2040 board. But, I mean, we got to learn quite a bit about these flexible PCBs. They're pretty cool. There's a lot of cool stuff about it. You can make your circuit kind of hang out on the edge of something. Like if you've got something round, like with a rounded edge, you can make your circuit sit on it, which is pretty nifty. Conceptually, everything should work, and schematically, everything should work. But I guess what I'm going to do is start a new design and take these two components, put them in the rightful spots, put the keep out area of that plug in there again, and then start up again and figure out what I want to do. Imagine one could desolder with normal direct iron and melt one joint, slide a folded piece of Captain underneath to separate. Not sure I understand what you mean there. Desoldered with a normal iron. Oh, I see. Yeah, if I were to try to preserve this, I would probably use still the tweezers, actually. Tweezers are not, they don't have that much depth to them, and solder doesn't really stick to them because they're stainless. So what I could have done is, I guess, maybe move the tweezers down the length of it just so that it bends a little tiny bit and separates, and been a little bit more careful about not over flexing it. The way I was doing it just then is because the board is trash. It's not designed correctly and it doesn't work. Maybe it might have worked if I had done the direct wire to pin thing on this, but I didn't want to do that much work. So it's easier for me to spend the $20, $30, $40, $50 to just redesign the thing. I'll just, one day I'll drink a whole pot of coffee and I'll start in on the new design and make it actually work. The big mistake here, and what you guys should take away from this, is if you are taking over a chip in order to get those pads, where's a good one? Here we go. In order to get these pads here to stick, your best bet is to put them on the underside of the board. That's a no-brainer, and I should have been better about that. Just a no-brainer. Just put them on the underside of the board, and then you're going, you know, load them up with a little bit of solder if you really feel like it, although you could just place them flat and hold them there with a pair of tweezers, and then just apply solder to that pin, and that solder will bond to the solder, and you won't have any of the problems that I had today. So there's the lesson. Rage quit. It's still like a half hour of stream, like a half hour to an hour of stream that I would have still gone, but we're at a rage quit situation where I tried to make something work and it failed so spectacularly that I've got to go all the way back to the design, with my tail between my legs, but with a bigger brain. Our brain is a little bit more glowy, and we'll be able to actually put some of these ideas into fruition, and then I will have a single chip keyboard. Well, it'll have a couple transistors on it, but it'll single microcontroller board that will control my keyboard permanently. The other thing is, maybe I should get it stiffened. Not what you're thinking about. You're dirty brain. I can make them put a piece of plastic under the whole board. Although, what does that mean for soldering? If you solder with a piece of plastic there, does it melt? That might be what happens. So maybe I don't do stiffening. Maybe not. We'll just continue with it as sort of flexible as it was, and then maybe that'll be the other method would be to solder whatever that FPC cable is. FPC cable is about the pin pitch of the microcontroller. So if I soldered that down and then had pads on the board, I could get a thin PCB. Yeah, you can actually choose the material of the stiffener. I don't know which are the ones that are solderable, but I will need to use hot air to solder the RP2040 down because it's a quad flat no lead with a heatsink on the bottom. I wonder about the heatsink. Do I need to have vias under that heatsink? How do you do that on a flexi PCB? Hopefully it doesn't get that hot. I mean, in my experience, the RP2040 doesn't really get hot. What did they do on the module here? On the PicoPi? Yeah, they got a couple pins. They got a couple pins there running heat sinking duties. Although the FR4 I keep saying. On the flexi PCB, everything's so close together, maybe it'll just act as a heat sink anyway. Yeah, I'm not exactly going to be running it at the new speed. No, 600 megahertz they got out of it. That was the news today. 600 megahertz out of a PicoPi. which is pretty good. Or was it 8? You might be quoting the right number. I haven't looked at Discord in a minute. That's not Discord. 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 They got it to surprise boost unlocks. Oh, come on. Visit site. RP2040 gets a surprise speed boost, unlocks an official 200 megahertz mode. 200 megahertz out of that thing. The Teen 4 is, I think, 600, which is absurd. When you're talking about that, you're talking about like picosecond timings and stuff. It's ridiculous. So, all right, anyway, I am done. I'm done. I'm frustrated. I wish I hadn't done anything today. This is a mistake. This is all a mistake. Streaming, getting to know you guys is all just a big mistake. I am going to slink away under the rock from which I came, and I will be back tomorrow. And we're going to clean up around here because things are getting a little ridiculous. So I'm going to give you guys the end card, if I can find the window. Really? You can push it past 400? For what? For the, that's for the RP2040? Here is my end card. That has all my social medias in it. Both of them. I'm always on Discord. I'm on Discord way too often. But I also have a Beaskie. I've gotten off of the hell site known as Twatter. I'm done with that. So yeah, anyway, I still have the account there. I'm just not going to do anything with it. And apparently the Knowledge Fellowship still updates there. They really should pull the plug on that one. I've got these expensive little pieces of flexi board to now throw out. I will be on Discord. You guys can catch me there. Yeah, I'll see you guys later. Who would I suggest that we go to? I'm having trouble with rating people. Because what I do is I basically bolt upstairs as soon as the technical difficulty screen goes away. I go straight upstairs and I take the dog for a walk. So, Somersault. Ghost Freak is doing some stuff. Dex Bonus is still going. Sir Lar, Rip Tracks. It's all the big names. All the big names are still going. Broken Lore Low for Rob Oz. All right, well, anyway, nobody else is streaming. I don't see Flatulent Gonad or any of the other folks out there. I think Tater's games might be streamed. I'm not sure. Check my Discord. It's in the stream announcements. But I will catch you guys later. I'm going to be back tomorrow. We're going to do something that's not soldering and getting frustrated. We're going to be throwing stuff out and getting frustrated. Have a good one, everybody.